Hello, everyone. I hope you are doing well. Uh, I hope you like the bit because we get to continue the bit where I say that we start each stream with the most voted upon Math Pesto puzzle by supporters. If you would like to become a supporter of the stream, uh, if you support at the windmill level or higher, you too can look at the list of potential puzzles and vote on which Math Pesto puzzle you most want to see us start with. So today, the supporters have voted for us to start with the Math Pesto puzzle Wildflowers, which I have been told by a little bird is Math Pesto's best puzzle. So we'll see how it goes. Funnily enough, after doing this bit for a while, last stream's Math Pesto puzzle wasn't actually by Math Pesto; it was actually by Jay Dyer. But we have once again returned to Math Pesto. So this puzzle was voted on by the following supporters. So in addition to honoring them, I want to say thank you so much to the support from all of these people. Nordy, Chef of Death, Ken, Doomdiat, Luda, Josh, Russ, Math Pesto, and David. So thank you so much for all of your support. So with that, let's try and see. It looks like my camera and the rules are in a reasonable orientation. Of course, the rules scroll slightly. Is there a recommended betting tree, Math Pesto? Because I see Math Pesto is in chat, so perhaps there is a recommended betting tree for the stream. Or sorry, not for the stream. For the grid. Row 6, column 14. Okay, at least this grid is only 15 by 15. I think last stream we did maybe 2 streams ago we did a Math Pesto puzzle that was like 17 by 17, which is like a lot more than 15 by 15. All right, so let's try and understand the rules of Wildflowers, and then we'll maybe understand eventually why it's called Wildflowers. Oh, it's 16 by 15. Good. I didn't even realize it could be not square, but it is not square. It's 16 by 15. So this is one of these, if you've not seen it before, Math Pesto has this series of Sudoku boxes hidden inside a Fillomino grid. I really want to do some variation of this because I've done a bunch of Math Pesto puzzles with this theme now, and I'm excited to try it for myself at some point. So we must here put into the grid 9 total Sudoku boxes. They have to be 3 by 3, so we don't get to do anything weird. They have to be 3 by 3, and they have to each contain the digits 1 through 9 once each. And I can't repeat digits in a Sudoku box. Am I wrong? No? I'm imagining this. Is this not how this works? This is apparently not how this works. Oh no, it's not a box in this one. It's not a box. Yeah, I just assumed when it said Deconstructed Sudoku that it meant it was a Sudoku deconstruction. But it is a different kind of Sudoku deconstruction than the Sudoku deconstruction I assumed. Sorry, so are there really 9 of them? There are 9 Sudoku regions, but they can be irregular in shape. So they could be something like that. Well, there goes my first digit that I had in mind. So yeah, there are 9 cell regions. We'll make them gray, and they can fit anywhere in the grid. They have to have the digits 1 through 9 once each, and within Sudoku regions specifically, we cannot repeat digits within rows or columns. Now, everything not in the Sudoku boxes is going to be part of the Fillomino zone, and so our traditional way of notating this is that things in the Sudoku zone are gray, and things in the Fillomino zone are rainbow. And in the we have a new patron, Franco. Oh, thank you, Franco. I feel like Franco was already a patron, but we'll get you a dance anyway. Thank you, Franco. Ba-ba-ba-doo, woo, ba-da-ba-doo, woo, ba-da-ba-doo, woohoo, waha, Wee! Woohoo! Thank you, Franco. Thank you. So within the Fillomino zone, we have to break things into ominoes following Fillomino rules. And so a Fillomino is just a collection of connected cells in which we put the same digit in every cell. And that, yeah, I was like, Franco is a term. I mean, there could be more than one Franco. It's possible. The world might have two Francos. I really have no idea. But welcome anyway, and thank you. So importantly, of course, within Fillomino, we always repeat digits in rows and columns unless it's a one by one. And so the Sudoku just does not see those digits at all. Alrighty. So there is, of course, a connection between the Sudoku part and the Fillomino part, which is as follows. And Russ now has been supporting the stream for 1 year. So thank you for a year of support, Russ. Let's get you a windmill dance. Thank you. Thank you. Woohoo! Waha! Wee! Woohoo! Waha! Wee! Woohoo! Waha! Ba-doop. Thank you, Russ. Thank you. Much appreciated. And so the thing that's going on here is that we have some x sums. So these arrows are always representing x sums. And so it points out that between an arrow, there's always a border between Fillomino and Sudoku. And so it's always the case that one of the cells on one of the sides of the arrow is a Fillomino and the other is a Sudoku. And then the digit here gives you the x sum total of the digits on the other side. And so if you've not seen like an x sum before, we could have this being a 6, with this being a 3, a 1, and a 2. And so what this 6 is saying is that 6 is the sum of the first 3 digits in this direction, the 3, the 1, and the 2. Now, how do we handle it if things repeat? Yeah, so, but notice this only works if this is, say, a Sudoku digit, and these are all Fillomino digits. And so if there's any sort of intervening Sudoku digits, then the intervening Sudoku digits don't count towards the x sum. And it works the same way if it's the other direction. Let's see. Oh, there's an example puzzle that I can show you, apparently. That's not the example puzzle. There's an example puzzle that I can show you. And so I'm guessing the example is just going to show me exactly the thing I just said, which is how it works with overlapping things. So, for example, this 11 here, which I realize you now cannot see suddenly, because I scrolled or something. Let's see, I can just switch to Penpa mode real quick. The Penpa mode has been demoted to the LMD example mode. But you can see here just how that works. This 11 is telling me it's an x sum for these two things. And so the 11 here, notice, is a Fillomino cell, because it's definitely not a Sudoku digit. And then it points at these two Sudoku digits, the 2 and the 9, which sum to 11. And this 7 here is a Sudoku digit. I notice Pesto has reversed the coloring of the way that I will do the coloring. This 7 here points at a 3, 1, 3, and those sum to 7. Again, always being wary that stuff that sort of, it only ever counts stuff of the opposite flavor of arrow. So I think that was the important distinction that Math Pesto was suggesting that I make sure I understood. In a rare instance of Zeta reading, I actually did understand that and was about to explain it, but I appreciate the check. Okay, so I'm going to draw in all of these lines because every arrow points at a border between Sudoku and Fillomino. So let's draw in all of these. These two arrows pointing at each other is interesting. I'm going to guess that they both have to be 1s, but we'll figure that out and think about it in a second. But I think they probably both have to be 1s. Oh, I did not put my face back. Oh, sorry, we did not re-enter Sudoku mode or Sudoku pad mode. There we go. How about that? Change scene. We need to get out of Penpa mode. I love the way that Nico phrased that. We have to go back, Kate, as they say. I don't know. Do any of you watch Billiam? I had never heard of Billiam on YouTube until a few days ago. But my boyfriend, who knew that I was a fan of Lost, linked me to Billiam's retrospective on Lost, which I originally opened and was like, oh, holy shit, this thing is 6 hours. There's absolutely no way I'm going to watch this. And then when when I started watching it, I realized that in fact it was not a single 6 hour video, that the 6 hour video was part 2, and that it's not only 2 parts. But spoiler, I watched the whole 6 hour video, and I greatly enjoyed it. So shout out to any Billiam fans out there. And any Lost fans, by the way. I am a huge Lost fan, so I am quite excited by doing this. Okay, so there's lots of interesting things. I first of all think that do I believe these both have to be ones? So let me just try and imagine. Yes, I think so these certainly have to be equal digits. Because whenever an arrow points at something, certainly that digit could never be larger than this digit, because it would be summing too many things, and then it would already overflow the sum. So these are certainly equal. Let me just convince myself they can't both be 3s, and of course they can't both be 3s, because then this would be saying that 3 is the sum of the 3 digits in this direction, and I'd need 2 zeros. And you can't repeat zeros in a Sudoku region, so that would be bad. So I believe these do both have to be 1s, and I believe we get an early digit dance, unless chat tells me I'm wrong. But I am going to do a digit dance anyway. Well, I'm not. I don't do the dances anymore. But we have Zach to do the dances. Woo! 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 Thank you, Zach. Thank you. And so, funnily enough, in one of these is a monomino Fillomino. And one of these is a 1 inside a Sudoku region. Now, the other thing I wanted to note is that there's a sort of very tight stuff going on in this corner. And so, if these two things work the way that they do, like if these two things are in the same region, or the same either region or same Fillomino ominoity or whatever, they can't be in the same one as that. So this would have to sort of sneak out underneath there, which is kind of interesting. So I'm looking also at this arrow, which can't be summing all that many things. In fact, it can only really be summing 1 or 2 things. So this number could be a 1 or a 2, I believe, are the only options. Oh, but this number can only be a 1, right? I think this number can only be a 1, while I'm slowly realizing how this works. This number could only be a 1, because how could I possibly sum more than one number in this direction? And therefore, that's a 1. And so the thing I was realizing about these ones is one of these ones is a Sudoku 1, and so I can't repeat a Sudoku 1 anywhere over here. So therefore, this can't be a 1, and so therefore it must be a 2. No, it can't be a 2. 2 is not a valid sum. No, it can be a 2. No, it can't be a 2. 2 is not a sum that you can ever get in the next sum. So my theory that this had to be a 2 is incorrect. What could it possibly be then? Because this could be summing that. Because it can't be a 1, because it would have to be a 1 pointing at a 1, and I can't have 4 1s in the row. But how can this possibly be a 3? Oh, right. Because this is the sum. That's the thing that has to be a 2. That's the 2. because this is the thing that tells me how many cells I'm summing. And so this has to be a 2. And therefore, it's either a 2 summing with that one or a 2 summing with that one. And so it's always a 3 that goes here, because I don't know which of the... I don't think I know which of these are in the same thingy thing yet. But I think that we do know that that is a 3 now. Oh, and this is a 1 as well, because, of course it is, because of the arrow going down there. So these are either both Sudoku 1s or both Fillomino 1s. And okay, so so this could be a Fillomino 1 if these are both Sudoku 1s. Or this could be a Sudoku anything if these are both Fillomino 1s. So this is either a 1 or it isn't a 1, is I guess my guess. Technically, I know that this is from 1 through 9, as I guess what my conclusion here is, in order to make that work. This digit here is... Sudoku regions can't touch orthogonally. I had learned last time that I assumed that was a rule and it wasn't, so I had just carried over that was not a rule. But apparently this time Sudoku regions cannot touch each other orthogonally. And so if Sudoku regions can't touch each other orthogonally, these can't be Fillomino 1s. Because if these were Fillomino 1s... Oh, wait, these could just never be Fillomino 1s. These are definitely Sudoku 1s. And so this is a Fillomino 1. So if these were Fillomino 1s, then I could not put a Sudoku digit... Sorry, I could never put a Sudoku digit here, so I'd have to put a Fillomino digit here, but what on earth Fillomino digit am I going to put? So these are both Sudoku 1s, and this is a Fillomino 1. Is the thing that I'm getting out of the fact that regions can't touch. And so, therefore, this is a Sudoku cell, and this is a Sudoku cell. This is a Fillomino cell now. And as a Fillomino cell, I am allowed to put boxes all the way around it. And now, yeah, this 3 and this 2, I don't yet know. Oh, no, I do know, because this 2 now, if this 2 were a Fillomino, it would crash into the thing here, so it's not a Fillomino. It is a Sudoku thing. So this is a Fillomino 3 over here. This Sudoku region has to get out. So we're going to sort of creep it out over like that. Let's see now. This thing is the... Oh, right. This is a Fillomino region because it points at a Sudoku region. So this is a Fillomino something. So the Sudoku region gets out behind it. This is a Fillomino cell also because it points at the 2. But it can't be yellow, because if it were yellow, these two would be the same digit, and they're visibly not. So let me explain that again, just in case you did not get that. These both point at a Sudoku cell. So they're both Fillomino cells. But the thing I just deduced is they're not the same Fillomino. And the reason for that is because this digit is the sum of these two, and this digit is the sum of these two. And so if these two were the same number, these two would have to be the same number. But that would be repeating a digit living inside of a Fillomino, inside of a Sudoku region, and that's not possible. So this yellow has to grow because it's more than... In fact, it's more than 5, actually. The minimum possible value of this is 5 because it's at least 2 plus 3. And the minimum value of this is 5 as well. That's going to push this gray Sudoku thing up here, at the very least. Something like that. Okay. So we've got lots of stuff going on down here already, which is good. I'm waiting for me to miss when I actually get to a 1 and know which of these is a Sudoku 1. Because as soon as a Sudoku 1 shares a row or column with one of these, we know which one is the Sudoku and which one is the Fillomino, but I'm not there yet. Okay, so let's look at other digits that can't be very large. So this digit can't be very large because of the fact that there's only 3 cells in this direction. So this is a 1, 2, or 3. Now 3 would of course be very nice. It actually can't be a 1, because if it were a 1, then this would be a 1, and then I'd have 3 1s in a row in a way that... Oh no, I could have 3 1s in a row as long as these two are both things. So actually, no, it could be a 1. But in any event, this is not a 1, 2, or 3. So I definitely have a border there. And so the red gets out, because the red is at least 5, because it's at least 2 plus this digit. And now that forces the yellow to get out, which forces the gray to get out, and we get our usual sort of Fillomino chasing activity. Like that. Oh. Yes, we did previously note that 2 arrows that point at each other are always 1s. I wasn't at all thinking about the fact that this was 2 arrows pointing at each other. So yes, these are both 1s because it's 2 arrows that are pointing at each other. I was only looking at that arrow and was like, oh, well, this arrow's useless because it could be huge. But you're right. We did originally prove that 2 arrows that point at each other like that have to both be 1s. And so so what that tells me is one of these is the Sudoku 1 for the row. So that's not a Sudoku 1. It's a Fillomino 1. And so that's a Sudoku 1. So we can box that appropriately. Yeah, I was not even thinking about that, fortunately or unfortunately, as the case may be. Let's see. Okay, so that actually gets me some action on the 3, because now the 3 needs to get out, and the 3 is not a 1. So actually the 3 is finished, which is sexy. There we go. Okay. So this digit's a 9, and it's a Sudoku digit because it's the sum of the first 3 digits in this direction. So this is a Sudokological 9. Oh, and these need to get out, so it's part of this region. Now let's count this region. 1, 2, 3, 4, 5, 6, 7, 8. Okay, this region only gets 1 more digit. Whatever that digit may be. Amy was telling me that this grew, which I happen to have just done. If this is the Sudoku 1 and it grows, that's going to bully all of this into like a very precise fashion. Oh, here's the thing. I'm thinking about what this arrow does if this is a Fillomino cell. If this is a Fillomino cell, I guess it would be a 2 with a Sudoku being a 3 there. Because it couldn't be a 1, because that would put a 1 here. So yeah, could this be a Fillomino 2 is the thing I'm trying to figure out. I know that this is a 1 or a 2. I should fill that in. This is definitely a 1 or a 2 because of this arrow. Yeah, in my brain, I feel like if this is a Fillomino 2, it grows that way, and then the gray is going to be forced out around here in a way that looks unpleasant, but maybe is possible. But maybe I'm trying too hard to force that, and I should do something else. This is always a 1 or a 2. And it's not a 1. So this digit's always a 2. Let me explain why. So it can't be a Fillomino 1, because a Fillomino 1 can't be next to a Fillomino 1. And one of these two is a Sudoku 1. I don't know which one. But whichever one is a... Oh, crap. It's that digit, not that digit. Sorry. this digit. This digit is, it's a Fillomino 2. So my deduction was right. I was just pointing at the wrong cell. Okay, so this is a Fillomino 2. I have not given Fillomino 2s a color yet, so this is a Fillomino 2. Whatever the case may be. And this is a Sudoku digit. And notice this digit has 8 cells in it. Or sorry, this Sudoku region has 8 cells in it. 1, 2, 3, 4, 5, 6, 7, 8. So that can't be Sudoku. This is definitely a Fillomino cell. Uh-oh, I broke it. What did I do wrong? Oh. Yeah, this 2 doesn't have to be Fillomino anymore. It's still a 2. No, it does have to be Fillomino because there's already a 2 in the row. The Sudoku 2 in the row is already there. But that's broken, so I misunderstand something. Oh no, I don't think so. I think this is okay. That's Sudoku. Right. I tried to make this a Sudoku cell for whatever nonsensical reason. I don't know why. But yeah, so that is a Sudoku thing. And this has to be a Fillomino cell because otherwise the 2 is broken. Like that. And therefore this is a Sudoku cell because it's pointing at a Fillomino cell. So we've got all of that. Let's see. Okay, this number could be basically arbitrarily large. Oh, also, chat, one of your responsibilities is to tell me when I have 9 gray cells in a row or column, because I suck at that. So row 15, column 11. What about row 15, column 11? Oh, that one. Sorry, that one. That column 11. Got it. Okay, so this is a 1 or a 2. And whether it's a 1 or a 2, it's because it's summing either this cell or these 2 cells. Whether this is a 1 or a 2, it's not a Sudoku 1 or 2. It's a Fillomino 1 or 2. And so this is always a Sudoku cell. Now it looks really bad to me if this is a... Oh, this just can't be a 1. Right, this can't be a 1 because there's a Sudoku 1 in the row. Okay, so I don't even have to think about it. So it's not a 1. And if it's not a 1, that means this is a 2. So it can be yellow. And therefore, this needs to separate those 2. Whatever this is. And in particular, that lets me 2 over to here. To finish... No, that's not true. Sorry. Don't listen to me. That 2 could still go there. Sorry, the 2 can still go down. So it's okay, but it certainly can't grow that direction. Now, if these don't join here, this is going to be weird for this, but I think it might be able to just get out under the bottom. I think it's possible. Okay. Oh, this is definitely Fillomino. Because this 2 needs to sum 2 Fillomino cells. Otherwise, it does not work. This is a sum of some number. Oh, this number can't be very large, actually, because there's at most 3 Fillomino cells over here. So this is a 1, 2, or 3. It's not a 1, because if it was a 1, that would be a 1 and would repeat the 1 in the row. So this is only a 2 or a 3, actually. And Yeah, I think that's okay. This needs to grow to be 9 cells. No matter how this grows to be 9 cells, it's always going to make that a Sudoku cell, because we need to get up to 9. I think it's being pointed out that 3 doesn't even actually fit, because if I try and make this 3, then it's going to look like that, and then the 2 is not going to have 2 cells in it, which is a problem for a Fillomino 2. So actually, it's just going to look like that. Boop-a-doop, boop-a-doop. 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 There we go. So yeah, agree. That is a 2. And so this is a 3, Sudoku logically, because it's the sum of those 2. Oh, it doesn't... Oh, well, it's the sum of, funnily enough, either these 2 or these 2, but if it's these 2, this one's also a 1, because 1 is the only thing it could be phenomenologically. So it works either way. It's always a 3. So interestingly, that now means this digit's not a 3, so this is more than 1. It's at least 2. This is at least 4. Oh, this digit just is a 4. So this is actually at least 5 in order to make this work. So yeah, this is a minimum of 5. So this is at least 3. I don't quite know what to do with it yet. If this is at least 3 and it goes here, does it break? Because this is a minimum of 3. So if I put a 3 here, that would be 3, 2, 2. No, that's okay. If it's at least 4, then I have a problem. I'm being told that row 14, column 9, I can write in. I have already written it in. Let's see. This I know is 1, 2, or 3. I should write in. This I know is 1, 2, or 3. I can write in. Okay. This can't be a Sudoku cell. Because if this was a Sudoku cell, there would be nowhere to put 3 in this region. That's slick. So this is not a Sudoku cell. It must be a Fillomino cell, and therefore it's a Fillomino 1. So therefore this now can't be a Fillomino cell, because it would have to also be a Fillomino 1. So therefore, it is a Sudoku cell, and therefore it's a 3. Because of that. And so now this region is done, this Sudoku region. And now let's remember the rules. This is therefore a Fillomino cell, because Sudoku regions don't touch each other orthogonally. It doesn't look like I'm dropping frames, Russ. Who knows, of course. The world is a weird place. Right. Neither of these can be a Sudoku 1, and if neither of them can be a Sudoku 1, this just can't be a 1 at all. This is Selena's point. And neither of these can be a Sudoku 1, so therefore that is a 2 or a 3. Row 14, column 7. Right. This can't be a 1. And therefore, Ambrose is pointing out, how many Fillomino cells am I summing? I therefore must be summing 2, which must make this a Sudoku 4, in order to make that work, which makes this yellow. Oops. Makes this yellow. I should probably change this yellow to be green. Actually, green is a terrible choice. Let's make it orange. So we have that. The 2 certainly can't grow here, because 2 is not the sum of 4 numbers. So the 2 grows here to finish. Now, the fact that this is a 4 at all actually tells me that these are both Sudoku numbers, because otherwise I could not get to 4 cells of Sudoku. So actually, the fact that this is a 4 is huge. It grays both of these cells. Now, the act of graying those cells makes red grow. Oh, I missed a border on the 2. That's true. makes red grow, because red, remember, is more than 5. Or sorry, is at least 5. Orange now has to grow because orange is at least 5. Now, spoiler, this digit's not at least 5, so it's not orange. Again, orange is at least 5, so orange has to grow. So this is a Sudoku cell. This Sudoku region has to grow, so it's going to come across here. This now isn't a 1, because there's already a 1 in the region. So that's a 2. And this is therefore a Sudoku cell. Or sorry, this is therefore a Fillomino cell. I wrote in the right thing. Could be orange, maybe. We'll think about it later. Red needs to grow, because again, red is also at least 5. Got that over down here. If red grows here, it breaks, because actually, neither red nor orange can take this cell. Because if red or orange takes this cell, then I need to have at least 5 digits of Fillomino in this direction, and I don't have at least 5 digits of Fillomino in this direction. So neither red nor orange takes that cell. So now orange again is at least 5. Red is at least 5, so red does grow here. Now this Sudoku region grows here, like that. So we have that. Okay. So this is a minimum of 3, but I don't think that's very interesting yet. Oh, actually, sorry. It's interesting in this direction. It's interesting in this direction. So how many of these am I summing? This can only be 1 or 3. Those are the only options. Hey, AFK. Hope you're doing well. Can't be 2, because there's already a 2 in the row. If this was 3, I'd be summing all of those. I can draw a border there. Row 11, column 4 is a Sudoku cell. Thank you, Sarvesh. Because it's pointed at by a Fillomino cell. Oh, this is a Fillomino cell because it points at a Sudoku cell. I've never filled that in. So I also get a border here. Let's see. If this grows this way, is that interesting? Or is it interesting if it grows this way? Well, this certainly can't connect to this, because whatever this is, it's taking one of these ones. So these can't connect, but I don't know that that immediately tells me anything of here. Row 11, column 7, AFK says is Fillomino, right? Because it points at a Sudoku cell. Agree. 3 is not oh, 3 is unavailable. 3 is unavailable. Very smart. Yes, 3 is unavailable because 3 is used in the row. So yeah, so they're each at least 6. That's true. So this is orange. Thank you, Egbert. So this is orange, and this is red. So that is going to get chased over there. Oh, this number can't be a 1, because then this would need to be a 1, and it visibly is not. So this is a 3. And so therefore this number is large. But how large it is not yet determined. Funnily enough, I know red can't be 7 because of this given 7. That ever prominent Fillomino trick of, okay, well, this is definitely taking one of these and finishing, so it's not a 7. Oh, this can't be a 7 either. Because if this was a 7, I would need 3, 2, 2, which is not possible. So this is not a Fillomino 7. So the 7 is not in the... So the 7 doesn't connect you. This is a Fillomino cell. Why have I not filled that in? That'll certainly make this much clearer. So this is a Fillomino cell, but it's not a Fillomino 7. So there's always a border there. That's the that is the punchline there. There are numbers larger than 8 or 9, right? I guess 10 is the largest it can be because it's 2 plus something. So 2 plus 8 is the largest. So this is a maximum of 10, I suppose. That is a good point. This is also a Fillomino cell while we are doing Fillomino cells. And this is the cell that people are saying is huge. Also, that forces this to grow. 1, 2, 3, 4, 5, 6, 7, 8 grows there. So this is the huge one. There needs to be just a rainbow button that just drops rainbow in a cell. That is another feature request for Sven. So can this be a 1? So I'm going to take a real quick break. I will be back in just a moment. Don't go anywhere. I will return, and we will do more. Oh, also, this is a Sudoku digit. I'm going to do that before I get up. And now these two can't join because they would be too big, right? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, sorry. I got distracted because I saw that immediately as I was getting up. I'll be right back. If I can find the be right back button. welcome back. Okay, we were just in the middle of sort of chasing this region up. So we're 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that finishes this this region over here. I had to also remember that I actually, since Tristan is at work, I should actually put a ping in the Discord. So I went and did that. There is certainly a border here because these are different kinds of things. This is certainly a Fillomino because it's an arrow. Fillomino. This is certainly Sudoku. This is certainly Fillomino because it touches a Sudoku region. And you're not allowed to touch a Sudoku region. Row 13, column 5 is a write-in. Ah, yes, this is 2 plus 1 is 3. That is a good point. I do believe. I like that point. That is from J. Dyer. So this number can't be very large. This number can be at most 2. I'm trying to decide if it can actually be a 1. But if this number is larger than 2, then it's at least 3, and it includes orange, which is at least 6. I guess 6 plus 2 plus 1 is technically acceptable. So maybe it can be as large as 3. But certainly not more than that, because it would try and put a digit here in the Sudoku thing that's way too big to be a Sudoku digit. This is the thing. This is the one I know is huge. So this is also Fillomino I should fill in. And I know that these are all in the same Fillomino at least. That doesn't really show up super well. There we go. These are all in the same Fillomino at least. That's true. 6 plus 2 plus 1 does not use a 3. That is a very good spot. Yeah, that also threw me for a loop, Jay. So yeah, this can't actually be a 3 because then this is, again, a minimum of 6, and then this would have to be a 0. So this can only be a 1 or a 2. But I do think it's possible for both of these to be 1s, which would also make that a 1, which would actually be convenient because it would disambiguate this pattern at the bottom that I have. It's a problem. Let's see, row 11, column 4 is a 2, Kryangoon points out. So it's not a 1 because this number is not a 1, but it's at most 2, because I'm summing at most 2 things. Right, so that's a 2. That is handy. Yeah, this has been a very very neat puzzle so far. I have enjoyed it. And I suspect we get to enjoy it a lot more because I don't think we're almost done. At least that is not the impression that I have. This number I know is at least a 2. Okay, what is this number? It's at least a 2 because the 1 in this region again is taken, but it's not a 3 or a 4. And there's no way it's a 5, right? Actually, I guess it could technically be a 5, can't it? 5 is the absolute most it can be. So this is a 2 or a 5. 5 would, of course, make this number enormous. 2 would make this number 5. This number is not small because it's a sum of all 4 of these digits, which must be pretty large. So this is also a Fillomino digit in order to allow that to happen. I think Ambrose has been trying to get me to fill that in for a long time. So now this Sudoku region must escape out to here, which puts in some borders there. The Sudoku region still must escape because it's 1, 2, 3, 4, 5, 6 cells. So it must continue escaping, resolving this 7. Works out in that, works out to be a Sudoku 7, which is not too terribly surprising. Yeah, so if this is a full, if this Fillomino region extends to there, then I think this ends up being a 5 in order to make this anywhere near big enough. So okay, here's the point. This thing is huge because it's a minimum of 4 cells, all of which are at least 1. So this is a minimum of 14. Well, this Fillomino that I have here that's a minimum of 14, it definitely takes one of those 2 cells. Oh, never mind. I was going to say, and therefore this can't be a 2, but that's not how 2 works. 2 is not counting those 2. It's doing that. But one of these numbers is enormous. And so if this is a 2, that's the one that's enormous. Okay. Now, I know that one of orange and red grows, because currently they can't both be 6. Because if they were both 6, I mean, there's all sorts of problems. So one of them grows. If red grows, it grows again, because red can't be 7. In fact, this number is a minimum of 4. So if red grows, red's at least 9. Seems okay to me. Let's see. Yeah, Ambrose is encouraging my darkest impulses by pointing out that I know that cell and that cell are the same Sudoku digit because of the red arrows. So we'll mark that. So let's see, how many digits am I at in the bottom row? 1, 2, 3, 4, 5, 6, 7, 8 at least. Because I'm noticing these arrows I can count as a Sudoku digit for sure. Let's see. Yeah, so that's always a 2 or a 3. That's always a 2 or a 3. This number is going to be a 9, and this is going to be a 45 omino. Oh, well, here's 2 more digits that can only be 1 or 2. And can never both be 1. Could both be 2. Actually, no, they could never both be 1 either. Actually, I think this is just a given if you look at it, actually. Because if one of these is 1, that's a 1, and the other one's a 1, but I can't have 2 1s either next to each other in Sudoku or Fillomino. That's adorable. So actually, these are both 2, and if they're both 2, that means they're Fillomino, which means that this is Sudoku. Because I know that because of the way these arrows work, these 2 are either both Fillomino or both Sudoku. That's the point that underlies all of that. And so, therefore, that digit and that digit are both Fillomino digits, because otherwise the 2 is broken. Therefore, this is a Fillomino digit, because it can't be 9 cells in size. So we get all of that being Philominomenos. And these 2 are definitely different digits, for whatever that is worth. No, these 2 are the same digit. These 2 are the same digit. Sorry, they're the same digit, not different digits. That can be black X. That both of these are. Let's see. This digit's now at most 3 because there's either... Oh, it could be 4 if it's Fillomino and all of these are Fillomino, which is maybe possible. No, that's not possible. This can't be a 4. Because if this is a 4, it has to be a Fillomino 4, and then the total includes this number that's at least 14, and so this clue would be like at least a bajillion d million d, and then I'd have to put the bajillion d million d number into the Sudoku grid. So this is not a 4. This is at most 3. Now, annoyingly, this is one of the places where I think it could still be a 1. But it's at most 3 anyway. And if it was a 3, it would be a Fillomino 3, for whatever that is worth. This number is at most 3, and I don't think I know anything else about it. Because, again, it's counting those. This number is at most 3, because it's... if it were Fillomino, it could be a 3. And it can't actually be a 1, because if this was a 1, it would make that a 1, and that would repeat a Sudoku 1 in the row. This digit is also at most 3. And can't be 1. No, maybe it could be 1. If it was 1, it would be a Fillomino, and that would be the Sudoku. Oh, that doesn't work, but it's a little tricky to see. If this is a 1, it must be Fillomino, which would make that a 1 Sudoku, and the problem is then this 1 Sudoku doesn't have anywhere to go that doesn't connect to a 1 Sudoku. So this is only a 2 or a 3. If it's a 2, then... this digit has to be a 6 because it can't be a 4. And if it's a 3, this number is a 7. So this number here is always a 6 or a 7. Oh, actually, let's look at this direction. Because this direction is also interesting. If this is a Sudoku digit, then that number is huge. And if this is a Fillomino digit, then this number is a 2, and that's a 3. Math Pesto, if this is a Fillomino cell, then it's a 3, in which case that's a 7. Because this can't be a 2, because if this was a 2, then that would be it would repeat 4 in the column, and I can't repeat 4 in the column. Unless you're willing to give me another option. But I feel like we exhausted all the possibilities. This number is a 1, 2, or 3. Again, with a similar sort of logic. This number is a 1, 2, or 3 with similar sort of logic. This number is at most 3, because although there's 4 digits up here, we know these two are one of each. So this number is at most 3. I'm again trying to decide if I know anything, if I know it's not 1, but I annoyingly don't think I know it's not 1. Yet. Cannot be a 4, Selena, because these two aren't of the same type. And so there's at most 3 of any one thing in these cells. Oh no, because I'm not counting that one. Selena's right, this can be a 4. Because I keep forgetting to count the thing that's telling me the number. So yeah, it could be that one of these, and those two could all be the same. So yeah, it could be a 4, sorry. You're completely right. Ambrose is pointing out row 11, column 13. Is that the right row 11, column 13? Can't be 1 for the same reason that I used recently. Because you'd get 2 ones of the same type touching. Ah, right. If this is a 1, then both of these are 1s, and they are 1s of the same type, because they both point at this. That's clever. Okay, so this is a 2 or a 3. That is a good spot to Ambrose. Let's see. Microstudy is looking at row 12, column 10. And noting that if this is a Fillomino 3, it doesn't work, right? So this only works if this is a Sudoku 3. Right. Okay, so MicroStudy's point is, if this is a Fillomino 3, there aren't 3 digits here. And if this is a Sudoku 3, then there's a 3 in the row. So there are sort of two different arguments. This is not a 3 if it's a Sudoku digit by Sudoku, and it's not a 3 if it's a Fillomino digit by math. So this is always a 2, regardless of which kind of 2 that it is. And if it's a Fillomino 2, it doesn't work. Because now if this is a Fillomino 2, let me show you in the bifurcation palette. If this is a Fillomino 2, then that's a 2, and that doesn't work because now I have a 2x sum, and that's not a valid option for x sum. So this is a Sudokological sort of 2. And now this is now an 11. Spoiler, 11s are always phenomenological. Because it's now just the sum of those two. So this phenomenological number, let's make it sky. Like that. Oh, this is a phenomenological number as well, because it's pointing at a Sudoku digit. This number can't be a Sudoku digit because there's both a 2 and a 3 in the row. And so because there's both a 2 and a 3 in the row, it must be phenomenological. There's a Sudokological 2 and 3 in the row, I mean. So this is always phenomenological, which means this is always Sudokological. Which means this is always Sudokological because it points at that, which means this is always phenomenological. Which means this is always Sudokological. Do I get to continue this chain anymore? Perhaps not. But probably, if I think about it, I can probably do more damage now. Maybe not. Let's see. How big is this now? 1, 2, 3, 4, 5, 6, 7. It's now 7 in size. It's interesting. Oh, row 9, column 1 lost its blue flash. I don't know how that happened. It's being pointed out by several members of chat that 2 plus 4 is 6. An important deduction that I had missed. It is a, let's try and get it a color. I think this one's not close enough to red. I think it can be a green. Go ahead and put that there. Row 13, column 6, I believe, is a 4. Yeah, there are several numbers we know are big. Yeah, this number is at least 10. Right. This number is at least 10 because it's pointing at a 4, and therefore this can't be a... No, that could still be a 2, because I don't know that these are in the same omino yet. But yeah, this number is huge, and it's not even at least 10. It's actually at least even bigger than that. But it's some giant number, because 1 and 2 are gone in the row. Is that useful? Is it true that even if this is a 5, I can't get high enough? Maybe actually I can prove that even if this is a 5, it's not big enough to be J's number. Because this would be 5, 8, 9, 10, 12. Yeah, even if this is a 5, this isn't big enough to be this gigantic number, because this number, this is J's point, is at least 3 plus 4 plus 5 plus 6, which is more than that number I just filled in. So actually, J's point does make sense, but it's completely not the way I expected this to work. So this is that huge phenomenological number. that huge phenomenological number is not 6. So we can chase that huge phenomenological number out here like this. I mean, it wasn't that I didn't think what you said made sense. I just was like, well, why is that useful? What am I supposed to do with it? And then eventually I saw it and was like, so that's what I'm supposed to do with it. So this thing has to get out. Okay, now notice this thing is a minimum of 5, so it also has to get out. This is a different omino than that one, but it has to get out as well. Continuing my omino chasing hobby. Now, again, it's at least 5, so that's always Fillomino. Oops, that's the wrong color. We're doing those with green. Now, this region still is not done, because we know we have 1, 2, 3, 4, 5, 6, 7 cells, so that has to be gray. Now, that's 8 cells, so that can't join this, so this is always phenomenological. That is the 9th cell of this region, 1, 2, 3, 4, 5, 6, 7, 8, and one of these ones is the 9. And remember, everything that touches a Sudoku region is Fillomino. So this is Sudoku. This Sudoku region now has to grow out to there, at which point this becomes a 1, because this region already has a 2 and a 3 in it, which makes that a 1, which makes that a 1, which makes that a Fillomino block. Now that makes this a Fillomino block. This is a reference to a Coke product from 20 years ago, by the way, if you were trying to figure out why I'm saying it in a funny way. The black digits are the same number. Or sorry, the black circles are the same digit. To answer Jay Dyer's question. So let's see. So we've got that's a 1. Is a 1 or 2. Let's see. That did a lot of damage. Row 10, column 5 is at least 9. Right, because now this is 3 plus 2 plus this number that's at least 4. So this is at least 9 is a good spot. And if this is at least 9, then red grows. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, actually, and becomes 9, in fact. Good spot to Isabella. So these are all 9s. And if that's a 9, that makes circle 7. And we can sadly get rid of the circles that Jay has just learned to love. So we have that all done. 1, 2, 3, 4, 5, 6, 7, 8. This is this is not at most 8. This is at most 7. Because it either takes that cell or it doesn't. And so this is either 6 or 7. And based on whether this happens to be 6 or 7, then this is either 4 or 5. I can fill that in just because it might become relevant at some point. Let's see. Oh, this can't be a 1 anymore, because if this is a 1, that would be a 1. So this is a 2, in fact, which makes that also a 2, which makes these colorologically yellow, which then makes these 6s, which does make that 4. Which also makes this 4, disappointingly. This now has to be 4. We just get all the 4s all at once. Let's see, row 9, column 4. Do I know anything about row 9, column 4? I mean, I know it's the sum of those two digits. Yeah, this is the one I know is at least 5. I agree it's at least 5. Just because 1, 2, 3, and 4 are gone from the region. Let's let's see. This is a triple. I should probably fill in what it is just for the future's sake. 1, 2, 3, 4, 5, 6, 7, 8. These are 5, 6, and 8. So funnily enough, if I put a Sudoku logical... Wait. Yeah, these are 5, 6, and 8. So what Sudoku logical number is left? It's only 2, 9, or 3. Not 3 even. It's 2 or 9. So the Sudoku number is a 2 or a 9 over here. Because those are the only numbers that are left in the row in gray. And if I put a Sudoku 2, would have to go on this side. And that's never going to work. Because... so I can't put a Sudoku 2 on either side of this. So the Sudoku digit here is always a 9. Now, I certainly know which side I want my Sudoku 9 to be on. But again, if I put a Sudoku 2 here, I'm either saying... Wait, no, sorry. My argument that it's not a 2 on this side is nonsense, because there would be a Fillomino digit, not a Sudoku digit on the other side. Never mind, never mind. Retract. Yeah, these are from 5, 6, 7, 8. Right. Ambrose is pointing out that there are 7 cells currently here. That could be an 8th gray cell, but this is always gray. In order for this to get to 9 cells. Hey, Nell, how are you doing? I hope you are doing well. So this digit here is either a 4 or a 6. Those are the only options for this cell. I'm just going to note. Because this is either a 2 or a 3, and we know what the sum is in each case. This is a 4 or a 6. Okay. Oh, what are you rehearsing for, Nell? Sounds like it's at least exciting. It could not grow if this was Sudoku. Oh, that's not 12. Sorry, this is the 12. Right. If this is Sudoku. Sorry, I chose a bespoke row 15, column 12, whereas Ambrose wanted the more sort of supermarket row 15, column 12. This row 15, column 12, if it's a Sudoku, it would grow here, and now the Sudoku region has 10 cells in it. So this is always a Fillomino, which means this is always a Sudoku digit. Let's see. Row 7, column 1. Yeah, this is at least 18. I agree. Right. Okay, yeah. So right. We've done more geometry since we calculated that this was minimum 18, and Garian's pointing out that that now actually lets us fill in that this is not part of this region, because that would become part of this sum, and that's never going to work, because then the sum would be enormous and not equal to a Sudoku digit. And so Garian has pointed out that now actually we can go back and we can expand this thing here. And now this is not a 1, because that would make this a 3, and this region already has a 3. So this also expands, which is going to make this also expand. And so we're going to get another giant rainbow here and another giant rainbow here. Just to make that work. row 15, column 12 is only 2 or 3. Sorry, that's the 12 again. By arrow. Right, if this were 4, that would already add up to too much. So this can only be 2 or 3 just by virtue of the row. And so if this is a 2, that makes that a 4. And if this is a 3, it makes that a 7. So this is always a 4 or a 7 in order to make that work. J. Dyer claims that row 11, column 3 is a sum of 6 in 3 cells. So yeah, so this digit is part of that, and so it can only be a 1, 2, or a 3, because there's already a 3 here, and so really the point is I need to sum 3 more, and so this needs to be a 1 or a 2, but it's not a 2, or sorry, it's not a 3 or a 1, so it's always a 2, and so that's a 5, and as soon as that's a 5, then I actually know what this omino is. It now is an 8, 9, 11, 12. This is now a 12 omino, as you do. We're going to give the 12 omino a color, since we know its size now. It is going to be... let's see, Simon's sweater has not appeared yet. We'll make our 12 omino Simon's sweater, and then I can get rid of the green so we can actually see the size now that we know the size. So we've got that. Nope, that's Simon's sweater. Yeah, this is Simon's sweater. Just for contrast, this is Hunter. So here is Hunter next to Simon's sweater. I have to remind us this is a 12 sometimes because it's illegible. Totally fair. Chat will probably remind me it's a 12 sometimes because it's illegible, but what can you do? Okay, so I'm noticing this digit here is a minimum of 3. But it's also, I think, a maximum of 3. Because this phenomenologically can't get bigger than 3. So I think this just has to be a 3. So it's a minimum of 3 because 5 is the minimum digit I can put here. So this needs to be at least 3. But if this was any larger than 3, I would have to fit it in 3 cells. So this just is a 3. Which then makes that 3 there. Well, this is only a 2 or a 3, so if this was more than 3, it could not go up, is the point. Now... yeah, this is the 2 or the 3. But this digit's definitely not a 1, is a thing that I am noting, because there's already too many 1s in the row, and it would force 2 more 1s in the row. So this is either a phenomenological 3 or Sudokological 2 or 9. I guess both of which are somewhat feasible, unfortunately. I'm trying to look at this arrow and decide if I can see anything. I don't think I can quite see anything yet, but I suspect they will be collapsing soon under the weight of all of the things looking at them. Row 7, column 7. Right. Okay. So this is Ambrose's point. If this were Sudoku, it would be the last Sudoku digit along this diagonal, and it would need to be a 1 in order that... sorry, it would be not the last Sudoku digit along the diagonal. It would be the last Sudoku digit in this sum. And therefore, it would be a Sudokological 1 or 2. Sorry, it would be a Sudokological 1, because I've already got the 3 and the 2, but it can't be, because there's 1 in the row. So this, therefore, is not Sudoku. I did a terrible job of explaining that. If it were Sudoku, it would need to be a 1 in order to make this x sum to 6 work. Could this be a 1? Would make that also a 1. It would, of course, be a Fillomino 1, and that would be a Sudoku 1. That seems okay. Let's see. I think this can be a Fillomino 1 without being a Sudoku 1, right? Oh, right. But the point is, it's still, if this can't be a Sudoku 1, it's just not a Sudoku cell at all. That's the point. And so, therefore, this is a Fillomino cell, and therefore it is a 1 because it's the thing that completes that. Got it. Okay, I was saying all the right things and then not noticing what they actually did. So there we go. Very nice. So now we've got yet another Sudoku 1. So therefore, this is not a 1 anymore because of that. Trying to see if this 1 does anything. It might not do anything. Hey, Jay, I hope you're doing well. Let's see. I should fill in this triple because there's only 3 digits left. 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't think any of those see any of those things as of yet. Is it row 14? Hey, by the way, AM. AM 1028. Always good to have another power of 2 in chat. I hope you're having a good day. Row 14, column 12. Isn't this a Sudoku digit? So the last Sudoku digit of this region, I think, goes in one of those 2 places. Is it a problem if it goes there? Oh, right, 1024 is the power of 2. Right. I got it confused with the next one. 2048. Right. So if this is a Sudoku digit, Jay is helping me understand AM's point. If this is a Sudoku digit, then the 2 Fillomino goes here, and then the 3 Fillomino doesn't get to 3 cells. So this is not a Sudoku digit. This is always a Fillomino digit. And therefore, that's the last Sudoku digit of this region. Going like that. Okay. Okay, and so... Yeah, okay, so we know that these together make up at least 5 cells. In fact, they have to make up exactly 5 cells, so this also has to be Fillomino because I need to get to the 2 and the 3. And I'm not going to get to 2 plus 3 is 5 without doing that. So that's actually always part of the 3. And these are a 2-3 pair in some order. And that's now a Sudoku digit, and it's going to tell me the order of the 2-3 pair because this is a Sudoku digit. It must be a 9, because there's only 2 and 9 left in the row, and 3 plus 3 plus something is not going to be something that is going to be 2. So that's the 3, and that's the 2. And we can draw the little border between them and be in good shape. And now this arrow is done, points out Nico, so it's a 5. So now let's fill in the rest of this. This is a 6, 7, 8, 9 again. That one's not a 9, at least. The row 15 arrow is also done, Ambrose points out, because that's now a 4, because it's 2 plus 2. Okily dokily. This is Fillomino and that's Fillomino because they touch a region, and you're not allowed to touch a region if you're a Fillomino. And so therefore, this needs to come out like that, just to have possibly get out. And so this Fillomino is of at least size 2, so it always gets out. And these are in the same Fillomino-omino. So if this were a 2, it would make this a 4. Oh, and it can't. So this can't be a 2 because it would make this a 4 because it would be 2 plus 2, but there's already a 4 in the row. So this is a 3, which actually makes this an 8. And we can do a little bit of coloring in order to make that look right. Like that. We can do a little bit of sort of filling in that stuff over there. So that 8 is going to knock 8 out of a couple cells over here, like that. This is not there. Row 13, column 14, arrow. I think that's already filled in. It probably was not at the time Ambrose said that. So interestingly, if this is a 3, it has to be a Fillomino 3. No, sorry. If this is a 3, it has to be a Sudoku 3. So it could place a Fillomino 9 there. Let's see. So if this is a Sudoku digit, it's a 2. Otherwise, it's not a Sudoku digit. I don't quite know what to do with that yet. Row 16, column 6, people are trying to get me to look at now. It's definitely not a 5 because there's a 5 in the column now. And because of this 8 over here, actually one of these two is definitely 8. And so that looks down and makes this a 6. So those are not 6. I believe that originated with Ambrose, but then chat worked together to get Zeta to see it. Row 13, column 10. See, J40 says this is always 7. So the point is this digit is always a 2 or a 3 because it can only grow into 2s and 3s, and it's not a 1. Actually, maybe it's a 1. Sorry. So this is a 1, 2, or 3. So if this is a 2, then these two don't actually add up to enough to get to any of those numbers. So this is never a 2. This is always a 3. I think I may be unraveling Jay's point in a different way than Jay unraveled it. And so now the point is this can't be a 3 because now that would create a 4-cell 3-omino. And now this can't be a 2 because that would make this an 8. So this is a 1. And so now we can do our coloring like that. And so our 3-omino finishes like that. And so we end up with that, and that, and that. And that actually finishes this 3-omino as well. Hey, Kenneth, I hope you're doing well. Whoop, and whoop. Like that, and that has made that a 7. So these are not 7. Okay, so that was all very interesting. And so now this blue color has to get out, which now makes this green color get out, which now makes this rainbow region get out. Which now makes Simon's sweater get out. Like that. So we can draw in yet more borders. Border nonsense. Okay, so this is now known to be a 6, points out J. Dyer, because it's 3 plus 2 plus 1. And this is now 3 plus 1 plus 2, so this is now known to be a 6. Oh, and it's a Sudokological 6, I should point out, because it points at a... Oops, that's the wrong gray. Because it points at a thing there. Oh, there's a border here. Oh, and this touches a 3-omino, so it's definitely not a 3-omino. So this is a 2-omino by the rules of Fight Club. So that's a 2. It's yellow. We can box all of that in like that. Now, there needs to be a 4-omino in one of these two cells in order to make this 6 work. Or a 3 and a 1, maybe, possibly. This needs to be Fillomino, because I'm summing 2 Fillomino digits in order to make that work. Now, is there any way this is not a Sudoku digit? This would be 1, 2, 3, 4, 5. Yeah, there's no way this is not a Sudoku digit, because we could take at most 8 cells in this region if this is not a Sudoku digit. So that's a Sudoku digit. And so now this is 1, 2, 3, 4, 5, 6, 7 cells. So there's definitely a Fillomino digit down here somewhere, is the point. If this had been a Fillomino cell, we could take at most these 8, because remember, I can't take these both sides of this arrow, Selena. Oh, actually, maybe, sorry, maybe I could have done... I might be able to do this. I think exactly that, I think would... Oh, that doesn't work either. This is 9 cells, but it's broken because I need a second Fillomino cell down here. So I think I was right, although I think I did neglect a case that I did not think about. So we have that there. Now, this digit, I don't think I know anything about. Oh, but this Sudoku region only has 2 cells in it, so it certainly has some more cells in it. And so that certainly makes these both phenomenological in nature. Just to make that all work out. And this is phenomenological in nature now because it points at a Sudoku cell. Good. And this is going to be some who knows how many cells, a bunch. Or one of those. Row 10, column 11 is not 11. That's a good point. So J. Dyer is correct. This omino is an 11 omino. If this were an 11 omino, I would need to sum 11 cells and somehow get to a number that could fit in a Sudoku cell. That's probably not going to work out super well for anyone involved. So therefore, my little sky blue region grows, and my green region grows, and my rainbow region grows. And Simon's sweater grows, and actually grows over here as well. So let us figure this out. So now this is now a Sudoku digit, and it's not a 2, because if this were a 2, we would be saying that 12 is the sum of 2 Sudoku digits, one of which is 2. That doesn't work. So this is no longer 2. It's true that rainbow, which is large, has to keep growing, and that's going to finally let us finish the 6 omino now that we continue this. So this is now done, which now is going to make all of these 6, of course. It's going to make sky blue continue growing, which has made this a phenomenological one. which has made this a Sudoku logical one, which has made that go over there. Now this Sudoku region has to keep growing because it's nowhere near done yet. Go loop and loop like that. This region is an 11, so it's not at 11 cells yet, so it has to keep growing. Sorry, that's the wrong blue. So this is a minimum of very large. 3 plus 4 plus 6 plus 5 is 18. Yeah, and we're not at 18 yet. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 cells currently. As things sit. Did that one do anything? Yes, it did. It made this a 1. Is the point. Because of that. Okay. So Russ says row 14, column 15. Can't be a Fillomino digit, because what would the Sudoku digit above it be? Okay, so if this were a 2, that would be a 4. And if this were a 3, that would be a 9. And this can be neither 4 nor 9. Very good spot. So this, therefore, is a Sudoku digit. That's a great spot to Russ. And now, if this was a 3, I would need all 3 of these to be Sudoku digits. And that's too many Sudoku digits. Because I don't get that many Sudoku digits. So this is, in fact, a 2. And so this is, in fact, a Fillomino digit because it's a naked single nothing. It sees 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a... so this is, in fact, another Fillomino 1, and this is my Sudoku digit. Usually, Pesto does not use the naked single nothing deduction, but there is a naked single nothing deduction. So this, by the way, this is a Fillomino digit. And it's certainly not a 1, because it points at a sum of 2 and something. So this is also that. That's not a 1 either. So this is, in fact, more than 4, actually. Well, sorry, it's at least 4, I should say. I'm going to fill in these cells just to make my life easier. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and this one can't be many of those things. It's not 1 or 3. So these are a 5, 7 pair. So these are not 5 or 7. They are 1 or 3. And that one's not 1 because there's a 1 in the row. So in fact, that's 3 and that's 1. I think J. Dyer wanted me to do some Sudoku here. So now, this is at least 7 now, at a minimum. At least 5. Now, if this 7 turned out to be a Sudoku 7, that would be really convenient for this cell. Now, which of the... So this is, yeah, I can just fill in that this is a 7 or a 9. And not think too much about which one it is yet, I don't think. This needs to be at least 3. Row 12, column 12. Ah, right. Okay. This needs to be, right. This is the deduction I tried to make earlier and it didn't work. But Jay is correct. If this grows here now, 6 is 2 plus this 7, 9 number. That's not going to work. So therefore, this 790 region grows up here. And this digit is a 4. Because I now need to make sure I interrupt that. Now, I don't think I've given a color to polyominoes yet. So I think polyominoes can be our carnival cake color. So let's grow... uh-oh, it disconnected, but seems to have reconnected. It was a very brief disconnection, I hope. Let me know if you had a horrible blip, but I think that was a brief disconnection. 1, 1, 2, 3, 4, 5, 6, 7. Okay, so this is either equal to 7 or the bet tree is a 9. Those are the two worlds that we live in. Had a frozen zeta. Well, hopefully I am now more animated. I try to be fairly animated on these streams. Got to keep it exciting. Uh-oh, now your zeta is blurry. Oh no. It says I'm not dropping frames, so hopefully if you just change the zeta quality, it will make me less blurry. Okay, it's a 7 because of the row 11, column 12 arrow. I need to figure out where that is. Ah, right. Okay, so yeah, so this is either 2 plus 7 or 2 plus 9. Well, it's not 2 plus 9, so therefore this is, it's being pointed out, a 7, which makes that a 5, and that a 7. Which now means this 7 is phenomenological, not Sudoku-logical, because I can't repeat Sudoku-logical digits in a column. That would be morally reprehensible. So we now have to get those things there, and we now have to give 7 a color. 7 I don't think has a color yet either. 7, let's get Hunter in the mix. It seems about the time in the puzzle where Hunter should be allowed to participate in the puzzle. This definitely isn't a 1. So whatever it is, it grows. Because if it was a 1, that would be a 1, which would repeat the 1. It also touches a 1. So there's lots of reasons why it's not a 1. Take your pick of which of them you like best, which means this is phenomenological, which means that this gray grows up. 1, 2, 3, 4, 5, 6, 7. Oh, also this is a 9. I should probably fill in that it's a 9. I bet chat is yelling at me that I should fill in that it's a 9. This is not a 9. That's not a 9. So that's a 6-8 pair in this region, so that makes that a 9. Let's see. In this row, what do I have left? I'm going to pencil mark all of this nonsense. Apologies, but I'm going to do it just in case it becomes relevant. 1, 2, 3, 4, 5, 6, 7, 8, 9. Because I see that here I see a 3 and a 9 and a 5. So those are actually a 6-8 pair. Here I see a 3 and an 8. So those are from 5, 6, 9. Here I see a 5 and a 6. So those are from 3, 8, 9. Here I see a 6 and a 9. And here I see a nothing, I think. Did I get any whammies out of that? I don't think I quite got any whammies out of that yet. But now I can do the same thing with these. 5, 6, 7, 8, 9. And see if anything nice happens. That's not a 7. That's all I can do. That's not a 5. I can do that. That's not a 5 either because of that 5. Row 11, column 6. That 6 sees over there and makes that an 8, which is nice. So thank you, AFK. So that's not an 8. And so that is not an 8. Let's see. So there's... Oh, and that 6 looks up and makes that a 9 and a 6. And that 6 now looks up and rules 6 out of all of these. So this at least has to make it out of this column at some point. So one of these two, I think, has to be a... Oh, it could be up there. It could be at the 6. Let's see. That 6 now makes that not a 6. Let's see. Okay. Have I done all of my relevant Sudoku now, or is there more Sudoku that I can do if I actually look at the grid correctly? So, Russ, it might look like these are the same color, but actually this is Simon's sweater and this is Hunter. Hunter got confused with Simon's sweater a little bit last episode and got a little bit upset about it. So we'll try and take care of Hunter this time. But yeah, I don't think they're going to run into each other. Is there any way this is a 2? No, because 2 is never a an x sum. So this actually grows one more up to here at least. These digits I should fill in 2, 3, 4, 5, 6, 7, 8. And does that one see anything interesting? It sees a 7. Well, it's not going to be an 8 anyway, because it's at absolute maximum. If I look down this diagonal, 1, 2, 3. This is an absolute maximum of 3, just because there are only 3 Sudokological digits here. If this were a 2, then this digit would be a 3. And if this were a 3, then this number would be huge. And I think it would be too huge. Let's see. The absolute minimum, if this is a 3, the absolute minimum this would be is 9. And if this is 9, it definitely takes up to here and then breaks this cell, because now this is an 11. So it's not 3, this is a 2. Which means this is a 3, which is great, because it lets us just fill it in. Like that, although I should not put green borders on things. That will, I'm sure, rapidly madden people. And understandably and correctly so. These are now Fillomino digits for sure, because I can't fit a Sudoku region here anymore. Okay, yeah, and I actually don't know the bet tree isn't a 1. That's true. Okay, so so this is a good spot to J Dyer. If I put a actually, is it true that the blue needs to get out? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah. Okay, yeah. So actually, yes. So the blue must take one of these two cells. If it tries not to take one of these two cells, it's never getting to 11. And this 18 plus 1 definitely needs to get out. And so these two both get out through here. And so, in fact, actually, rather than rainbowing these, well, I can rainbow that one. This one's got to be the blue one, because they can't crisscross. And so that's the blue. And so that's the rainbow. That's very smart. So just these two huge ominoes needed to sneak out through this gap, or they weren't getting big enough, which now has made 1, 2, 3, 4, 5, 6, 7, 8 for our Sudoku region. And so these aren't 3 anymore. What can this digit now be? 2, 4, 7, or 8, it looks like. And it's not, of course, it's not actually 2, and it's not 4 either. So this can only be 7 or 8, which means that these are each 3 or 4, whatever they happen to be. So blue currently, what did I do? Oh, 7 minus 2 is, sorry, sorry. I see what I did now. I don't know why I got to 3 or 4. It's 5 or 6. And so that's also the 5 or 6, whatever it might be. So I can get rid of the X's and replace the X's with some nice green lines, because whatever this is, since it's 5 or 6, it definitely also takes that cell, which makes that over there go like that. And now, since this is at least... Oh, no, I don't know that this extends. It's been pointed out there is now a 2 in this region, so actually... 2, 3, 4, 5, 6... Oh, this region's done. So this region now being done now means that these are Fillomino. And that 6, I have somehow miraculously seen sees down. And that 8 now sees up, placing that 8. That 8 has made all of these 6s, which has made that also a 6. 6 actually has a color, so we can actually get rid of these. And make all of these the color of 6, which could be the title of a hit Sudoku novel. This must be a 6, because if it's not a 6, we either put 2 1s together or 2 2s next to each other. So this is also part of that 6. Yeah, to avoid the weird domino thing that happens if you are irresponsible with your Fillomino. Let's see. There was a hint that I might have all the digits in a column. 1, 2, 3, 4, 5, 6, 7, 8, 9. I do. So these are rainbow. Thank you to Selena for pointing that out. And now all of this is rainbow because I can't fit a region up here. Well, this is going to be fun to try and disambiguate. So we've got that happening. Now, J. Dyer was telling me if I counted, I could find one more of here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, right. So even if this takes here, that would only be 10, so it always goes up here. So we've got that. So now the question is, can this be a 1? Annoyingly, again, I think so. Because if this is Sudoku, it has to be a Sudoku 1, but I think it can be a Sudoku 1, annoyingly. Just because there's only Fillomino digits after it. Row 7, column 12, Screaming Ice Cube is telling me I should look at. Row 7, column 12. Ah, there's a 4 looking at it. So that is a 7, and that is a 4. That 7 looks back over here and says that is only a 5, 8, or a 9. Row 5, column 7 now. Ah, row 5, column 7, because of Sudoku. It's a 4, right. Okay, good. So now there need to be 4 Sudoku digits up here, and so one of those is a Sudoku digit, that's a Sudoku digit. These both need to be Sudoku digits in order for that 4 to work, which means that this is a Fillomino digit, for sure. Well, a Fillomino number. It might or might not be a digit. Who knows? So we get that. And so this 4 can't point to an 11 is a good point. I'm trying to think about what this can be now. So this can be a 3 if it's a Sudoku digit. If it's a Fillomino digit, it can only be a 1, which would put a Fillomino 1 down here. Maybe that's okay. But I will take Ambrose's point that... I will take Ambrose's point that this can't go here, or I would have to have 12 Fillomino digits, including a 12 that sums to 4, which sounds unlikely. So we will extend Simon's sweater over to here. I will remember that I need a 6 in this region. And one other digit. What's the... Oh, yeah, okay. 5, 7, 8, 9, something like that. Yes. So how many digits am I adding together to get 4? Ilm is pointing out it can only be 2 digits. And so this is all... Oops, that's the wrong yellow. That is a 2 and needs to have a 2 immediately next to it. Very clever. And so Simon's sweater escapes again, which now forces this Sudoku region to finish like that, which creates much rainbow. Happy Pride Month. Boop, 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 boop. And so I know one of these two is a 6. I don't know which one yet, but I'm just going to mark that because I noted it earlier and I don't want to forget it. Simon's sweater is a 12. So we're going 1, 2, 3, 4, 5, 6, 7, 8, 9. We need to grow at least these 2 more. Stop. What did I do? Oh, the 2 doesn't have to be next to it. Right. The 2 doesn't need to be next to it. Right. Right. This does have to be a 2, but the other 2 could be over here somewhere. That's a good spot. Okay, thank you. That was nearly a catastrophe. Well, here's the thing. This is definitely a Fillomino digit, because I can't fit anything in there. It's true that 12... So, almost everything I deduced, though, was forced. Oh, yeah, so then the 12 region now has to come over here, because otherwise it would make this into a 14, which now does indeed finish the Sudoku region like that. And the 12 region's not done, so it needs to come up at least to here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It needs to go up at least that far. Okay, and so that does make the this the 2, because otherwise the thing. So we get that. And these are still Fillominoable. Now that is over here. Do I know anything about the size? Apparently I knew this wasn't a size 1 omino. I don't even know. How did I even know this wasn't a size 1 Fillomino? Did I really know this wasn't a size 1 Fillomino? It must be part of something. It's part of this. Right, it's part of this. So this is either a 3, a 6, or a 9. Those are the options. Okay, and so it does grow here for sure. We don't know if it grows beyond that or not. 3, 6, or 7, sorry. Apparently 9 and 2 plus 9 are different. How many regions do I actually have now, by the way? 1, 2, 3, 4, 5, 6, 7. So I need 2 more, one of which is actually maybe one or both of which are these 2. Oh no, they can't be these 2 because there's one over here. Ah, there's one over here, so these have to connect. Now that doesn't tell me how they connect. It just tells me that they have to connect. And the fact that they have to connect tells me that this is not a Sudoku digit. Because if this was a Sudoku digit, it would be a 1. To make that a Fillomino 1. And that would not work because I'd repeat 1 in the region. Because again, I need my other region over here. Oh, the left one can connect? 1, 2, 3... Sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, it is just big enough to connect. Darn it. It's very unlikely, though. I think the odds of that are essentially 0. Like, I'm certain we could prove it if we had to. This digit is at most 4, but it can't be 4. So, this is 1, 2, or 3. Connecting to the 4 is completely impossible. This omino is huge, right? This omino is enormous. In fact, speaking of the fact that this omino is enormous, let's actually embiggen this omino, which will actually give us our sort of start of our Fillomino region, or sorry, the start of our other Sudoku region. Again, this has to be huge. Row 8, column 4 is a hidden 7 in this region. Very smart. So yeah, so this is a 7. Because the 7 in this column is ruled out by that. Let's see. These are actually 1, 2, 3, 4, 5, 6, 7, 8, 9. And that one I know is not an 8. That might be literally all I know, though. Let's see. Okay, so so that has now forced this to be a 3-omino. Is Nico's point, I think. Sorry, is Ilm's point. So that has made this into an honest 3-omino, which has made this a 5. Which has made none of these 5. That 5 sadly does not quite look down at that 5-8 as much as my brain wants it to. This number has to be quite large. It's probably a 4, but who knows? Column 7 can be pencil marked 1, 2, and 4. Oh, 12 and 4. Right. Okay, so yeah, the 12 and 4. So yeah, this is a 4-cell 12 sum that's a Sudoku 12 sum. Is got to be 1, 2, 4, 5. So I know that these are from 1, 2, 4, 5, and so that one's not a 3 in particular, and this is from 1, 2, 5. And the 5, this is Selena's point, will look down there at the 8 and the 5. Weren't you one of the people who voted for this one, Naverio? This has Naverio voted for it all over it. Was I wrong? Did I misremember? It's possible. I did read the list of names at the beginning. So yeah, we've got some 1, 2, 5s up there. Let's see. The windmills can have what they like. Naverio does not actually remember. I do not 100% swear I remember either. Okay, so I feel like we should be able to force this. I don't especially relish the idea of forcing it, but I think we probably can if we try hard enough. And maybe I'd still have to argue something about what happens over here. Or doesn't happen over here that I don't necessarily want to. Rainbow grows further. This is today's voted on math pesto puzzle. Yes, Nebu, that is correct. I'm not sure which this rainbow, because this rainbow was let's see, it's currently at 13 plus 5, it's minimum 18. So yeah, so maybe this is going to have to grow a bit. So currently it's at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It could take that and be 12, 13. So it's got at least 5 more cells. So it's always taking this cell at least. Oh, and all of these I know are all rainbow. I know that goes that way. And so that's going to force blue. No? Math pass just as I did that wrong. Row 7, column 10. Oh, could be part of the 11. Okay, sorry. It's the... Sorry, it's not the extension that's the objection. It's the fact that I did that. Yeah, that one corner could be blue, right. Now the 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Unfortunately, yeah, the blue could go here. So so this does not, in fact, we don't know that it has to extend up the blue. Oh, and the blue could even go over here, so that doesn't even, so that's not even quite correct. I do know all of these are different. Polyominoes that move diagonally. That does sound especially egregious. Oh, so this one can't join here. Wow, I was wrong. I was certain of that, but the 1 can't join, because if the 1 joins, I can't make my 1, 2, 4, 5. So, so in fact, these don't join, which is crazy. Okay. Oh, no, 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 no. So the 1 can join the 4. The 1 can't join this stuff. The 1 can't join up here, where I have, because there is a 1 in Sudoku in these cells that does not join this 1. But maybe the 1 joins this, and this combines, and then this region goes over here or something. Well, there's 3 Sudoku regions left, and 2 of them have to join up. But this one's not joining to that one. So yeah, there's some deduction to be made. There are 2 left. So all the 1s are gone, I guess, is one deduction we could make. So if all the 1s are gone, this isn't a 1. I guess I already knew that wasn't a 1. Is there anywhere else I can use the fact that I know it's not a 1? Yes! Yes! This thing. We can now resolve. Because we said previously that the only way that this could be a Fillomino digit... Sorry, the only way this could be a Sudoku digit is if it was a 1. It can't be. There are no more Sudoku 1s left. So this is a Fillomino digit, and this is a Sudoku digit. In order to make that possibly work. Now, let's see. So if this now is not a Sudoku digit, I can't get this to anywhere near 9 cells. So this has to be a Sudoku digit. We finally got the deduction that I wanted to make before in this rather contrived way involving counting 1s in 2 remaining regions, but hey, we got there. So let's see. If this is a Fillomino, then this is going to grow over up there. So this certainly... Okay, let's pencil mark this. So, so these could both be 1s. And if this if this is a Fillomino digit, it has to be a 6. No. I feel like there's still a lot of options, actually. This feels tedious, unless I'm missing something. Oh, no, okay, I think I... If this is a Sudoku digit, it's a 1, 2, 4, or 5. It's a 1, 2, or 5. 3 column 7 is not 3, is what you're missing. Right. This is never 3. That's the point. Because if this was 3, it would need to be a Sudoku digit, because it would be summing all of these. But that's not allowed, because these aren't all... because there's not a 3. So this is never a 3. So there doesn't have to be one AFK. Oh, there is. Sorry, there is one in this column. It's either there or there, I suppose. Is there any way this is a Sudoku 5, though? There's no way this is a Sudoku 5. Right. There's no way this could be a Sudoku 5. So this is always a Sudoku 5. This is the kind of case hacking I really don't like. So now we have to think about, so are these both Sudoku digits? In which case this would be a Fillomino 3 or a Fillomino 1. Or is this the Fillomino digit? In which case, is the point that this is always a 2? No, sorry. Is the point that this is never a 2? No, I still don't quite get what I'm supposed to get out of this. I did believe that if you thought about it enough, this couldn't be a 5, so that had to be the 5. So if this is a Sudoku digit, it has to be a 1, because you can't make a 2x sum. So if this is a Sudoku digit, it's a 1. If this is a Fillomino digit, then it's a 1 or a 3. So I think this is always a 1 or a 3, is I think the actual, like, if you really list out every possibility, I think that's every possibility. MicroStudy wants me to think about this number. I mean, this number's big. I don't see what good thinking about it is going to do immediately. Hey, Nicholas. 3 and 4, column 2. Oh, just reading that sounds disgusting, Naverio. That sounds horrible. Let's see, so Navario's point is that if I think about what happens if each pair of regions connect, and count the minimum size of this, then there aren't going to be 20 cells if these connect. Because these are going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 is how these would connect. And now there would be this many cells, which is 12, 13, 14, 15, 16, 17, 18, 19 cells in total. And so these would be a minimum of 3, 5, 8. 3, 5, 8 is 16 plus 4 is 20. So yeah, that does not work. So these two can't connect. This is in the running for my least favorite step in a puzzle of all time, I must say. But don't worry, KNT has that. He knows what he did. So these two can't join, is the point. In a somewhat disgusting deduction involving... I see why MicroStudy likes it, because it's a taxi-cabbing deduction. Let's see. Something to aspire to. So what does it even do that these two can't connect? Because there's 3 things, and I only need 1 connection between the 3. So I need a second way to do this. So there's 3 things. I need 1 connection between the 3 things. And so what Naverio has done is to disprove 1 connection. We have to disprove... So, okay, so these 2 can't connect, and we also know these 2 can't connect. And therefore, these must connect. Right, okay. So the deduction I really liked about the 1 is the other break. So we need 1 connection out of these 3 things, And there's this can't repeat the one says these two can't connect, and the can't connect these two that says those two can't connect. And so therefore these two must connect. And if these two must connect, we have to do it very diligently. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think we have to do literally exactly that. I think anything else is not going to connect them. And so now we hope this is 12. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so this is that. Could be row 3, column 6. Right. This doesn't have to be in it. Sure. One of these two is, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, it's going to finish on one of these sides. And, one of these is going to be the last one. All of these are going to be Fillomino because they're definitely going to be the border. These are going to be Fillomino because they're definitely going to be the border of this region. And so this one now is going to grow a lot. And it's not going to grow to connect. This is a 1. That's the point. This has to be the 1, because now this region's essentially done. These two now have to connect. And therefore, this is a 1, because I need this to be a 1, because I can't put the 1 up here. And this now has to be gray in order for this to work. This is Fillomino. This is a 2. And let's see, we've got some more bordering we can do. I know these two are in the same Fillomino for sure. How many is that? That is 1, 2, 3, 4, 5, 6, 7, 8. There's one more cell in here. If there's only one more cell, that cell's never Fillomino, because that would require 2 more cells to get to. Now, this was a minimum of 20, and now I think it needs that cell in order to get to the minimum of 20. So I think all of this needs to be part of the rainbow. Okay, and so I think that is going to resolve this did have to go down like that. Simon's sweater does have to come over like this. This is here. This now as a 20 omino can get a color. So its color, let's see, have to think through it. I think royal purple for the 20 omino. We can get rid of this line through the 20 omino. So this is size 20. And if that's a sum of 20, I needed this to be 4 plus 3 plus 5 plus 8. So none of these are 9. And so that is a 5. That's a 3. That's an 8. And that is a 6. And this is the other one. This is the 9. So we've got all of that going on. That probably resolved some Sudoku somewhere. Maybe not, actually. I can fill in 12s in all of the rest of this. Just to finish that off. Let's see. So this is at most 5. But it could just barely be 3. So this is 3 or 5, I believe. If it's 3, these are an 8-9 pair, which doesn't immediately break that I can see. Oh, it does, because these can't be 8 and 9. This can't be 8 or 9. So this can't be 3. Because if this is 3, in order to get to 20, I need these to be 8, 9, but that one can be neither. So this is a 5. So these cells sum to 14. Sure. Let's see. Yeah, this is 2 plus something. Well, this omino certainly has to grow. It's 2 plus a number that's at least itself 2. So this is at least 4. So it certainly grows over to here, is the point. And so that's going to block off some of the area that this region could take. Again, minimum is 4, so these are all together. Let's see. Row 4, column 6 is a naked single, I am being told. It's not 1, 2, could be 3. It's not 4, 5, 6, 7, 8, or 9, so it's a 3. These digits are something 2, 3, 4, 5, 6, 7, 8, 9. So this is not a 2 or a 7 or 9. This is not a 6 or a 7 or a 2. This is an 8 or a 9. This is not a 2 or a 7 or a 6. This is an 8 or a 9. So those are an 8-9 pair, which makes that a 6. Makes these not 6 or 8 or 9. Makes them a 2 and a 7. Over there. Oh yeah, I'm going to have to disambiguate these 8 9s with some stuff going on over here, aren't I? It's going to be weird. What is actually looking at these 8 9s? Or maybe there's something looking at one of these 6s. Ah, this 4. No, this 4 is not looking at anything. I don't see it. Some arrow somewhere is looking at one of these, this messes. So now we can resolve the 20 sum, I'm being told. So again, those sum to 9, so these need to sum to 11. And so it's either 2 plus 9 or 7 plus 4. And it's not 7 plus 4 because there's a 4 in the column. So this is 2 plus 9, which makes that a 7. It's going to be this one. This one's going to do it. There we go. That's the point, is that this is going to only be able to see one, but not both of these, and that's going to fix everything. We actually know what this is now, actually. So this now actually is 4 plus 3 is 7, plus 6 is 13, plus 5 is 18. So this is now an 18 omino. So 8, sorry, not, wow, that was a mess. 18 omino. And so it can get a color. The 18 omino is going to be human flesh. This has to be part of the... Oh, no, sorry. This has to be either part of the 18 omino or part of the region. That's the point. Okay. So we can get rid of this. So now that this is an 18 omino, we have to ask ourselves what this number is. But this could be in or not is also part of the point. So let's write in what's left in this region and see what happens. So we've got 1, 2, 3, 4, 5, 6, 7, 8. So this certainly is not a 7 or an 8. So this is 3 or 4, and it's not a 4 either because there's a 4 in the column. So that's a 3. Neither of these is a 3. So so these two need to sum, sorry, the next two digits, whichever they have to sum to 15. And so it needs to be, one of them is a 7, so the other has to be an 8. And so the point is now that has to be the 8 because there's an 8-9 pair in the row. So that's an 8 and that's a 9 is the point, and this is a Fillomino cell. Otherwise, I won't get that. That makes sense. So the point there was, in order to get an 18 sum that included a 7, I had 2 digits that had to add to 15, so I needed an 8, and there was an 8-9 pair that told me I needed to use exactly that 8. This is now an 18 sum. Wait, did I just assume this was an 18 sum when I didn't know it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. No, I did know it. I just didn't actually include it in my thing. Okay, this is definitely an 18 sum. So we have that. So now this must be a Sudoku digit because we need an extra cell in there. And so now the human flesh has to connect around here. 8 there, 1 in the corner. And so now the 11 omino, the sky blue one, must finish there. Oh, no, sorry, that's not true. That's not true. It could come into here however it wants. Don't listen to me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, actually, this has to continue over here. Sorry. Human flesh isn't anywhere near done. So that has to be where the 11 omino finishes, right? 4, 5, 6, 7, 8, 9, 10, 11. Yes, that is the end of the 11 omino. Whoop, doop. So these are also 18. Okay, the 18 omino can't take that cell because there aren't 18 cells up here. So we can draw in that border and extend the human flesh. This isn't a 1, so whatever it is, the sum definitely also includes that cell. And if the sum includes that cell, this cell's also not an 18. So again, this is an 8 with a 1. And now that cell has to come over here. So this is also human flesh. Human flesh is not 7. So the 7 has to come out like that. Do I have a color for 7s? I do. 7s are hunter. Let's make that hunter. Put in that border. I don't know, this isn't a 1 yet. Okay, this just can't... Oh, sorry. What is this? This number is not large enough to include the 7. So this is certainly a 2 or a 3 are the only options for this cell. So this is not part of it. In fact, I actually know this is a 4 because now it's 2 plus 2. So this is a 4. We can finish it up like that. We'll do that. 4s were carnival cake this time. So this can be a carnival cake 4. In order to make that work. So now these two are in the same omino. And so if that omino were size 3, we'd have to do 3, 3, 3, 1 in order to make this work, or 3, 3, 3, 2, 2 in order to make this work. Can the 18 actually not take this cell? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yes. The 18 can take that cell instead. That's a good point. There are only 7 cells that Hunter can take. That is a good point. So if there are only 7 cells that Hunter can take, and Hunter has size 7, Hunter better take all of them. We're going, I see, Math Pesto has dipped into the micro-study school of putting givens in your hybrid Fillomino puzzles. I see that trend is spreading. So therefore these are 2s. So they are regular yellow. So those are 2s. Oh, Math Pesto started it? That's fair. Uh, so these are... I mean, I don't have any complaints about this part. Uh, oops. 2, 8. No, 8. 8. There we go. This part's all fine. So that's a 4. So this is a 7 or an 8. There's a missing border in the last column. Ah, there is a missing border in the last column. We'll have to figure out what exactly is going on with this 6 omino later. I couldn't tell you at the moment exactly what's happening there. So neither of these is a 1, so therefore this is just a giant 3 omino. Which is cute. The sky is 11. We can figure out what happens with the sky omino. Okay, and so now we get to figure out that this is a 7 or an 8. We squint and don't see anything yet. Is there a clue or is there just Sudoku? It's either a clue or Sudoku, one of those. That 8 needs to move down a little bit and it would help fix things. That 8 looks down. There we go. That 8 gives me the 9, which gives me the 6, which gives me the 8 over there. That 8 gives me the 7 and the 8 up there. That all, I think, makes everything done except for figuring out that this 6 region takes the rainbow tree, making the rainbow tree a 6. Lovely puzzle, except for the 1 step. Aside from the 1 step, I really liked that. The sort of chaos regions here work very well with this idea. Well, of course, it's a taxi cab step, so of course MicroStudy loves it. But yes, that is all very cool. I really am enjoying this series of puzzles that sort of combine Fillomino and Sudoku in various ways. That they've all been very sort of they've all done a good job of sort of creating a rule set that I think you could never make a second puzzle with. But that has a cool, like, especially the beginning where you're like, what on earth am I supposed to do with any of this? How many givens were there actually? I didn't pay attention. 2, 3, 4. There were 4 givens in the puzzle. If Henry liked the step, then so do I. I mean, fair. It's interesting because I think there have been a lot of steps in this series of sort of counting-ish Fillomino arguments that I have liked more than I usually like counting arguments. Oh, there's a hunter... Ah, yes, there's a given hunter 7. Yeah, there we go. I can see how this would be an absolute nightmare to try and disambiguate without givens. As much as there is something elegant about grids that just have arrows in them, it is... And it's never going to be as bad as the given shaded cell in Miami, so it's not so bad. The givens, but yeah, this rule set in particular seemed particularly challenging to do with that. Yeah, so that was yeah, under 2.5 hours. I'll take under 2.5 hours. No, it's over 2.5 hours. How many hours is 2.5? 2.5 hours is 150 minutes. Yes, if I'd have named the given shaded cell, that would have made it special. Although it's funny, and everyone I know who I've watched solve it has, like, not even really noticed the shaded cell in the process of solving it. It's just, like, it just didn't occur to them that the cell was shaded by me and not by them, because it just does not come up until the end, and then when you have it, it just tells you what you need, and then the puzzle solves. But I liked the ending of it too much to not use the shaded cell to resolve it. Otherwise. Very cool. I liked that a lot. That is true. The given shadeds are often not the same shading color that you're using as a shading color. I'm also very interested that Math Pesto colored it the opposite way that I did. So I was sort of inclined to color all of my ominoes and make the Sudoku things gray, because that's sort of what I've learned from the previous puzzle. But I noticed Math Pesto did exactly the opposite and made every Fillomino cell gray, and then gave each region its own color. I guess maybe that would have highlighted like what was really happening up here at the very end with all of this nonsense. That we needed to like really think about, like, are these two the same? Are these two the same, or whatever? Interesting. Yeah, very neat puzzle. I liked that quite a bit. All right, I'm going to take a quick break to stretch, and then I will be back and we'll do another puzzle. So fear not, more puzzles are coming. right, welcome back. Let me post a link in chat in case you are interested in doing this puzzle. Uh, I realized that I have been doing essentially no Sudoku puzzles on stream for the past forever. So I figured it was a good time to do one. Oh, let me, by the way, message Tallcat and tell him that I'm doing his puzzle. I'm waiting for MicroStudy to tell me I already did this one. Uh, uh, I'm going to try and make a concerted effort to do just a little more Sudoku on the stream. I did try and put a Tallcat Renbon quad puzzle in the bucket, which Tristan assured me I had not done, and then I think Matt Pesto pointed out that I had in fact already done it. This sells that cell too. MicroStudy, or sorry, AFK if you're looking for all of that sort of thing. So here we go. Here is a Sudoku puzzle. Well, I mean, if the Math Pesto puzzles count as Sudoku puzzles, then have these. Yeah, have you been streaming much, Naverio? I feel like I used to get notifications that you streamed all the time, and I don't know if I messed up some setting somewhere that now I don't, or if you've just only been playing Civilization. Because I try to visit Naverio stream because I really enjoy Naverio stream. Okay, Naverio streamed twice in the past month. Okay, that sounds about right. I did stop by at least one of those 2 times, I know. All right, so how does this work? So this is a regular Sudoku puzzle where I need to put the digits 1 through 9 in every row, column, and box, except the boxes got a little wonky. So this is a box, and this is a box that got especially wonky. And along each of these purple lines, I need to make sure that I put a string of consecutive digits. So for example, this could be a 6, 8, 7, 8, 7, and that would work. What on earth is with my keypad and sometimes having a long lag? It should not take the Bluetooth signal like an appreciable amount of time to move from my keypad all the way over to my laptop. I don't understand why that happens sometimes. It's some weird like Bluetooth air pollution thing or something. I have no idea. Anyway, so those are the rules. I don't know exactly where to put the bet tree, so I'm just going to put it there unless someone who's done the puzzle tells me something else. And then I will share with you the thing that AFK and I have noticed, which is that these 2 cells are the same digit. And the way you realize that is that this digit needs to go somewhere in this box, but I can't repeat digits along Renbon because then it would not be a string of consecutive digits. And it can't repeat in a row or column, and that only leaves that cell over there. Now, a similar thing is happening over here, so those 2 are also the same digit, exactly the same reason. Now, what's interesting here is that, actually, maybe I'm about to say something that's wrong. I was about to think about yellow in this. I certainly know I can sort of continue chasing yellow into the pyramid, and if I chase yellow into the pyramid, then I'll learn that one of these 2 is yellow. I was thinking about whether these digits went on this Renbon or not, and whether yellow was an extreme digit on this Renbon or not, but then I decided I didn't know. And so therefore that digit is yellow, just by looking in the Swivel region, and therefore that digit's not yellow anymore, and therefore that digit is yellow. And we get some more yellows. Yellow ruled out of all of those cells in this region. And now circle's not yellow. So now circle gets the privilege of being upgraded to being green. Because the reason why, if you're new to the stream and are trying to figure out why on earth I did what I did, which is to make these 2 a color and these 2 circles, is that I try to only color things if I know that they're different. So if I have a yellow and a green, I try to make it so that I always know the information that yellow and green are different. And so if I used yellow up here and circles down here, I was not assuming that they were not the same digit. Okay, so we know that they live in one of those two places. The green lives in one of these two places, and therefore the green is there. And therefore now if I look backwards, the green is there. And we end up with a similar pattern going on here. Now, we presumably can do even more with all of this. So it's interesting that this 6 puts interesting pressure on this Renbon. Oh yes, please do remember to like the stream. Thank you, MicroStudy. And welcome, Ace of Spades. Always great to see you. I hope you're having a good summer. Hopefully. If this Renbon has a 6 on it, that 6 can only be in one of these cells. Otherwise, the Renbon is exactly 1, 2, 3, 4, 5, which is incredibly restrictive. Selena's pointing out I know the yellow is down here in column 1, just because of where sort of column 1 is. Let's see, and probably I could do the same thing with green up here, like that. Let's see. So yeah, so yellow in the bottom right region. Yellow in the bottom right region is in one of these cells, and so the reason why Nicholas and Ambrose are pointing that out is because that tells me that the yellows in row 8 and 9 are a spoken for. So we call this a Jovi wing around the channel, because I need to have one yellow in here and one yellow in here, and there's only 2 yellows in rows 8 and 9, so therefore that is yellow. And now the yellow in this region now can only go here because it can't repeat along this Renbon. So that yellow now goes there. And so now we have... now we get the yellow in row 5 has to be 6, right? Because the yellow in row 5 can't be in a region with a yellow and can't be on a Renbon with a yellow, and so yellow is 6. And so we get to bring out Zach to do the 6iest of dances for the newly discovered 6s in the grid. What did I do? I highlighted that cell for no reason. Bring out the 6s in the grid. Ba-boop-ba-doo! Woo! Ba-doop-ba-doo! Woo! Ba-doop-ba-doo! Woohoo! Ba-doop-ba-doo! Ba-ba-doop-ba-doop! Ba-doop-ba-doop! Waha! Wee! Thank you, Zach. Thank you. Much appreciated. My summer's going pretty well, except that I'm getting eaten alive by mosquitoes this summer, much more so than normal. I feel like I don't usually run into hardly any mosquitoes, but somehow we do. Okay, so therefore, there is no 6 on this Renbon. So this Renbon is 1, 2, 3, 4, 5. For whatever reason. Oh, probably I can do exactly the same thing with green if I take half a second to think about it. And get that green is 3. Is that going to work out? Let's see. So green in the center region. No, green in this region is the point. So green up here forms a Jovi wing and places green in the eye of the pyramid. And so then green in the center region. Green in the center region now is placed there. So now green over here is indeed 3. So green is indeed 3. And these aren't green for sure. So these have become 3. And that is your little intro to coloring, I suppose. Okay, so therefore these digits are a 4 and a 5 in some order because there's no 2 on this Renbon that does have a 3 on it. I'm just going to change these to corner marks. So that's a 3, that's a 3, that's a 6, that's a 6. And then get rid of the color so we can hopefully color other things. So if these are 4 and 5, this 6 now is going with 7 and 8. And so now these digits have to be 1 and 9, because it's all that's left in the region. And now, yeah, this 4, 5 in the row is going with one of these. But where's the other 7, 8 going in this row is the real question. It's not going on a Renbon with a 3. So that's a 7, 8, and this is a 4, 5. Just to finish out the digits that are missing in this row. So therefore, there's always a 4 in one of these two cells for whatever that is worth. So let's see. And there's always a 7 in one of these two cells for whatever that is worth. These digits I know are, I should fill out, are 6, 7, 8, 9. And those ones aren't 6. So this is a 7, 8, or a 9. And there's no 6 here, so these are a 7, 8, 9 triple, in fact. Which is very, very personable. Let's see. So none of those are 7, 8. None of these are that 7, 8, 9. I'm trying to see if there's 7, 8, 9s that I can place in this box. Unfortunately, I think there's a few places for the remaining 7, 8, 9s in this box. Oh, Nicholas pointing out I should look at my own pencil marks because I already said that these aren't 7. And so therefore one of these is 7, and therefore this is not 7, which is a very good spot from Nicholas. So one of these two is 7, so that, for whatever it's worth, is not a 7. Those aren't 7s. Sure. Let's see. So if this is a 7, 8, 9, it's kind of interesting. This digit I actually know is a 7, 8, 9 because it sees the entirety of this Renbon. So I should fill that in for sure. And it's not a 7 because there's a 7 in the box over there. So this sees all of 1, 2, 3, 4, 5, 6. So it's a 7, 8, 9, except it also sees 7. So this is always an 8 or a 9. That feels important. Now, what can I do with that, though, is the next question. I'm not sure. That's a very slick spot. Okay, so J40 asks, where did these two digits go in this box? And the answer is they go there and there. Which is very interesting, because that means that's not the 7. So that is the 7. This is a 5, and one of those is a 5. That is super slick, both setting-wise and otherwise. So this digit is a 1, 2, 4, giving me a 1, 2, 4 triple in the row, also actually giving me an 8 over here, and a 7 there, and a 9 there. No 9 there, so there is a 9 down here, along with a 6. So we've got all of that. This has become a 4, and that's a 5, and that's a 4. And that is a 5 or a 2, but it's not a 2, because there's a 1, 2, 4 triple in the row, so it has to be the 5. Hey, Sarah, I hope you're doing well. Now this is an 8, because it's not a 7 or a 9, and therefore that's a 7, and that's an 8. This is gorgeous. Well done, Tallcat. Not that anyone is surprised. I'm looking back to see what this was rated in terms of difficulty. This is rated as 3 stars. Interesting. Okay. I will use my magic mark button to just figure out what's left here. And I will use the fact that I know that 1 doesn't go in a renbon with a 6. In fact, 9 doesn't either, because 9 would require 1 more digit than I have. So these can go with a 1 or a 5. So this is a 2 or a 4, is what we're saying, in order to connect those. Hey, Medhi. What did I do? Oh, when I said the thing wasn't a 9, I filled in a 9 in it anyway. That's smart of me. This is actually much better. So yes, when I said something wasn't a 9, I then filled in a 9, which created a problem. This is 4 or 7. I don't know which one yet, but that's not a 9. So therefore, that is a 9, and that has to be a 2 in order to make that work. So no 2 there. This I know is an 8 or a 9 just to finish the row. 9 isn't there. 9 is there. It's all the same, right? So that... Oh no, that 4 or 5, I still don't know quite what happens to it, but we will learn the secrets of the universe all in time, fear not. Let's figure out what's going on, speaking of secrets of the universe, with these cells. We've got a bunch of 4, 5, 7 business. This column needs a 1 and a 2. And the 1 needs to go in one of these 2 cells, because the 1's not going anywhere along this renbon. In fact, let's just mark this whole thing. This cell can only be a 2 or a 7, is the thing I was sort of seeing. And so if this were a 2, that would be a problem, because this renbon doesn't have a 3 on it. So this is a 7, in fact, actually. Which makes that a 4. Which makes that a 5. Which makes these a 1-2 pair. And is a little disappointing because we've got a 7 now. I guess now we know there's no 2 along this renbon, or whatever that is worth. Welcome back, Jay. I hope your disappearance and reappearance have been pleasant and unstressful. This is not a 5. These 2 and these 2 are certainly markable. We've got a couple places for an 8. There's a heart icon over chat. I don't think it's my fault. I blame YouTube. I choose to blame YouTube. We can fill these in. I am, by the way, ecstatic that I have not asked a single question about 5s yet in a renbon puzzle, which is delightful. That has placed the 5 on this, so that is the 5. Not that chasing 5s isn't fun, just that, it gets boring after a while. Renbon can do so much more than just ask where 5s are. Let's see. So, I can't quite get there. This is a 3. That has to be a 2. I, too, am loving this puzzle, Riff Clown. This is very much my style of puzzle. These are a 1-2 pair, which makes that a 4 and that a 5. Which makes these not 4. These are the same 1-2. Sadly, those are the same 1-2, so I don't get to make an argument about them seeing this cell, which would be a little bit silly. I might try and see if I can get away with it anyway, though. So we can now actually place the 5 on this renbon. So we can at long last ask about 5s, Nicholas and AFK have pointed out, because now actually this renbon does need a 5 regardless. And so this could be as low as 4, but it can't be 4 because there's no 4 in this renbon, so therefore this is an 8 or a 9. This renbon did end up being extreme. I thought this renbon wasn't going to be extreme. So now these are an 8-9 pair that look at this cell. So this is not an 8 or 9. That makes these a 1-2 pair. Makes these an 8-9 pair. makes these a 1-2 pair. And so I certainly can start coloring 1-2s and 8-9s. That's an 8 or a 9. So let us begin. That is the green 1-2. This is the yellow 1-2. That's the green 1-2. That's the yellow 1-2. That's the green 1-2. Now let's do the blue 8-9 and the purple 8-9 and the blue 8-9 and the purple 8-9 and the blue 8-9 and the purple 8-9. Row 3, column 1 is crying. Oh, yeah, row 3, column 1 is the last thing. It's the other one. It's a 7. I will do that for Rift Clown and Neverio. Let's see. So blue in row 1 now is placed... Wait. Where is blue? Oh, blue in row 1 is placed here. Because that digit can't be blue. None of these can be blue just by numbers. That can't be blue, so that's blue. Which is going to be rather large, because it's going to tell me that blue is 7, and it's going to tell me that 3 goes here and not there, and so 3 goes here and not there. This digit can't be an 8 or a 9, but it's next to an 8 or a 9, so it can only be a 7, which makes blue 8, immediately making it seem justified that I colored some stuff. So we can get rid of the coloring for the 8s and the 9s now. So no 8 there, no 8 there. Okay. These are from that collection of digits, but they're not 9, I can tell you that much. And one of them is a 4, so that's not a 4. One of them is, in fact, yellow. One of these two is green. So that's not... Oh, well, of course that's not green. Let's see. 4 in top left. The 4 in the top left region is placed, Nicholas points out, which is great. So that is 4. So this is not green. So that is green, which means that's yellow. For sure. And also means that's a 4, less importantly. But more importantly means that's yellow. So we get all of that. Excellent point, Nicholas. You got us many colors. That's also yellow, speaking of things that are colored, if I think about them. So I need to place yellow and green in this column. And I can put... Oh, I can't put yellow here. So yellow needs to go there or there, but green has a little bit more flexibility. Hey, Josh! I hope you are doing well. Because green could go here, annoyingly. But row 3, column 6, Jay points out is a 9. So because it sees lemon and lime flavor of digits. This digit I can probably just write in. It's a 5. That has become a 4 in this ongoing saga. That's a 1. And now green has become 2 through weirdness. That I think means that I didn't actually get anything out of the coloring, but shh, don't tell anyone. So these colors can dissipate. And so now we get an 8 and a 4. And probably now Mark will know what this digit is. It's a 2, which makes that a 7 and a 2. So indeed, that was where it was. That is a 9, a 6, and a 9, and a 1, and a 9, and a 7, and a 6, and a 1. And these are 4 and 8. And our bet tree, 1, 2, 3, 4, 5, 6, is a 7. So congratulations to all the 7 bettors out there. May all your betting tree wishes come true. Very nice puzzle. So smooth. I'd probably actually have gone 2 stars on that if I was rating it, but very good. I liked that a lot. I think I solved it wrong because the bet tree wasn't an 8. The other day, Tristan was doing stream management and looked over to me and said, "So when I'm entering what the bet tree worked out to be, do I write a 13 because that's what you said it was to troll chat, or do I write an 8 because that's what it actually was in the grid?" These are the sorts of discussions that we have behind the scenes. Okay. There is a Kodak 10 lines puzzle I still really want to do, but I am told it is quite difficult, so I probably don't want to do it now. But I will. I will do this kuraban double arrow puzzle. So let us see how this double arrow puzzle goes. It's a very colorful double arrow puzzle. I think I'm going to just randomly put the bet tree here and hope. So the way double arrows work, if you have not seen them before, is that the sum of these 2 digits at the ends of the bulb are the same as the digits along here. So, for example, this could be 3, 2, 8. And this would be a valid fill for the double arrow because 6 plus 7 is 13, and so are these. I did my best to sort of popularize this idea, so I enjoy these. And so a thing you often want to look at in double arrow puzzles is any place you have a whole bunch of digits like this, where I know that the minimum sum here is 11 for these digits, so these two need to add to at least 11. And the minimum sum here is 10, similarly, although that's not necessarily super exciting. Likewise, these sum to at least 10. In addition to the best puzzles, there should be a video ranking how the various digits did that year. That would be great. Like to take a moment to mourn the loss of the digits we lost this year. 13 is booming. There definitely was the triple 13 stream was very exciting. I was certainly surprised. Let's see. Probably I want to combine some of these, maybe, possibly. Parity is always possible if you know something about the parity. Okay, so these are length 1. That's also a trick, is you always want to look for length 1 double arrows. This notably not a length 1 double arrow. Actually, no, this isn't. No, there are no length 1 double arrows, right? Because these are not actually length 1 because red and white are different colors. It is true that column 4 is somewhat suspicious. There are a lot of circles in it. So I bet that's a 1. Well, wait. Where even is the end of... Oh, okay, this is a double 1. Okay. Ah! No, I could do 1, 9. Sorry, so the thing about a length 4 1 is that the minimum sum is 10, which makes it really hard to have a 1 in one of the circles, but it could go in a circle if it goes with a 9. Now, there's certainly no 1 in these cells, because there we go. In this box, if I use a 1, these are 1 through 4, then I can't put a 1 there. And so these aren't 1 and these aren't 1. So the 1 in this column certainly goes in one of these many places. But that's not... people are looking at like the minimum possible sum of all of these cells. So let me show you what people in chat are looking at is the sum of these cells versus the sum of these cells. And so the point is the sum of the yellow cells is equal to the sum of the green cells. And so the sum of the green cells is... well, there's some restriction. So you might think that these green cells could sum to 20, but they actually can't, because if you do, you put a 1, 2, 3, 4 quadruple in these 3 cells. So these assuredly sum to at least 21 at minimum. I don't think the same is true of these. Hello, Tristan. I don't think these need to sum to at least 21, but they certainly need to sum to at least 20. So that's at least 41 for the sum of these, which means that these yellow cells need to sum to at least 41. And so that means that this is 1, 2, 3, or 4. These aren't in the same box, though, right? We don't get the same alignment in putting 1, 2, 3, 4 in the same box because this one crosses boxes. I think, Selena. So if I don't put any 1s... Oh, no, I can't think about it. I was going to say, if I don't put any 1s, it jumps to 14. Is that too high? But I don't think that is too high. So the claim is if there's a 1, 2, and 3 in all of these cells, something goes wrong. In column 1, maybe? I don't quite see what people are seeing Sudoku-wise over here. Garion is trying to argue that these can't actually sum to 21, which in order to do that I would need to repeat 1, 2, 3 in all of these boxes. And so it would be 1, 2, 3, 4, 1, 2, 3, 5, and that would make these a 1, 2, 3 triple, which definitely does not work because these would not sum to enough. So actually the minimum here is something like something like 1, 2, 4, 5, 1, 2, 3, 4, I think, where that would end up being a 1 or a 2. I'm just looking at the rough minimum here, trying to understand this. That still doesn't work, actually, because I can't repeat the 4 either. Because if I do this, these end up being a 1, 2, 4 triple. That still doesn't work. So this is not even the minimum, because this is 2. The minimum is bigger than this. If I repeat 3 digits, the third digit has to be big enough that 2 of the digits can go here in these 2 cells. So they have to add... So 2 of the digits I repeat have to add to at least 10. So but I could do something like... Okay, so maybe the minimum, and I'm not 100% sure, maybe the minimum is this. So this would be 10. This would be 24. 24 would be a fascinating minimum. If this really is the minimum, then that forces a lot. Because then it's going to force these to actually add to 20, because of course the maximum of these is 44. So how do we prove this is really the minimum? So I guess I have to prove I can't make them sum to 23. And so if I make them sum to 23 or less, if I make them sum to 23 or less, I have to prove how many repeated digits that requires, right? So if I sum 8 things to 23 or less, what's the minimum number of repeated digits, is I think the question. Okay, sorry. Selena has the slickest way of looking at this, which is that if I repeat 3 things in total, that is, if I don't do this, if I repeat 3 things, 2 of those things sum to 10, because they're those 2 things. And so my total's at 20 just because I put those in both of these boxes. But then I still have more digits. I still have 2 digits in each box left. And certainly those digits sum to more than 4 between the 2 boxes. So that does not work. So this is forced. And so the point is that these are from 1, 2, 3, 4, 5, 6. I don't, of course, know how they're distributed. With a 1 and a 2 in both. And now that means I've got a 1 and a 2 up here. And of course, this has to be a 1 or a 2. And the 1 or the 2... and so I know the sum of all of these. The sum of all of these... Right. These already sum to 24. And so these need to sum to 20. And because that's 20 plus 24, that means my leftover has to be a 1. And so we get a 1 dance from Zachary. Ba-boop-ba-doo! Woo! Ba-doop-ba-doo! Woo! Ba-doop-ba-doo! Thank you, Zach. Thank you. And so these need to be a 2 with an 8 or a 2 with a 9. But there's definitely a 2 in there, which means there's definitely a 2 over here, because there's a 2 over here as well. Oh, right. I know these equal 10, so they have to be 2, 8, right? I was thinking about it globally, but locally I know these sum to 10, so it has to be 2, 8 exactly. Agree, which does put a 2 over up here. These also sum to 10, because those do. And I know the total sum is 20, and these sum to 10, so these also sum to 10. And so these are either 3, 7, or 4, 6. And now... so... let's see. Anti-Knight says this can't be a 2. Or you won't sum to the minimum, which is 11 in orange. Ah, good spot. Good spot. these two cells see a 1, 2, 3, 4 triple. Sorry, a 1, 2, 3, 4 quadruple. So these are from 5, 6, 7, 8, 9. And so Anti-Knight's point is, hey, these sum to a minimum of 11. 2 plus 6 is not big enough to be 11. So in fact, that's an 8, and that's a 2. These aren't 2, so one of these is 2. And even a 1 or a 2 here is not sufficient. This needs to be a 3 or a 4. And that means there's never an 8 or a 9 in these, and there's always a 5 in these cells in order to make that sum work at all. Likewise, this sum is also huge. These are also from 5, 6, 7, 8, 9. And so the minimum sum here is also 11, which means that since this is at most 4, this needs to be at least 7. So this can only be 7 or 9. This can't be a 1, or I won't get to 11. So in fact, that's telling me that I have a 1 up in one of these cells, so I don't have a 1 in either of these cells. So I do have a 1 marked across boxes in these cells. So so now row 1 actually is getting kind of interesting, because now, sort of, if I look at it, the minimum sum of these 3 cells is now 12, 13, 18, is Navario's point. So actually, I have to minimize this at 5 and 3, 4, 5, making that a 5, and these both 9s. And so that makes that the 5. Which means now, actually... and that's slick. Now the minimum here is 13, which is also the maximum of these two. Sorry, I put the wrong digit there. 4 and 9, which makes these not 8 or 9. That's super slick, which makes this a 3, which then by maths makes this a 6, which has made that the 1 and that the 2. These are a 3, 4 pair now, so... these are not 3 or 4. I can get rid of the pencil marking, which is assuredly going to screw me over. That's a 7, and that's a 6. Also very nice. 1, 2, 5, 6 is 14. So this digit's at most 5, because these are... actually, sorry, this digit can't be 5, because if this were 1, 2, 5, 6, it would be 14, but I've used the 5. So this digit is at most 4, but it's not 1 or 2. So this digit's always a 3 or a 4. That's not a 4, that's not a 3. And if this is not a 4, this is not a... sorry, if this is not a 3, this is not a 7. And if this is not a 4, that's not a 6. Is further things. Okay, what are these, Mark? Those seem to be 6, 7. So no 6s there, no 6 there, no 5 there, no 5 there, no 5 there, no 5s there, no 6s there. Okay. So is there any digit I have not marked in this column yet? Yes, there is, which is that there's a 5 in one of these cells. And in fact, actually, the 5 is just placed here, because I need to put a 5 in the column somewhere, and I have conveniently not put it anywhere else. So there's a 5 here. Okay, and so now, if this is not a 6, these are 1, 2, 3, 4, and they sum to 10, and this is a second 5, so this is a 6. So that's not a 6. Okay, so now there is a 5 down here, but there's not a 6. So the maximum here is 1, 2, 4, 5, which is 11? No, which is 12. The maximum down here is now 12, which is with 1, 2, 4, and 5. And that requires it to be 12, which makes this a 3, which makes this a 6, which makes this a 4, which makes this the other one. That is a 7. And so indeed, these are 1, 2, 3, 6, and these are 1, 2, 4, 5, which add to 12 as we learned in the last puzzle. 3, 1, 2, 4, 5. Right. Okay, so now let's mark in all of these digits because we know exactly what they are. In fact, that one we know exactly what it is. It's an 8, and that's a 9. And these are a 7 and an 8, so that's the 7 and that's the 8. 6 plus 8 is 14, which can only also be reproduced as 5 and 9, and I even know the order. So we get all of that going on. This is the super slick puzzle, as one expects from kuraban puzzles. Oh, it could be 6-8 again. Right, sorry. It could be 6-8 again. Right. It could be 6-8 the other way. So that's not 5 or 6. That's not 8 or 9. Right. It can repeat. Totally good point. So this sum is huge for whatever that is worth. Let's see. Do I have any other sort of filled in double arrows that are worth looking at? I should fill in the first row and this box. So I know that none of these are 3 or 4, so they're from 6, 7, 8. So where's the 7 in this box is the question. The 7 in this box goes here. Where's the 8 in this box? The 8 in this box goes here. See, I told you it was 9 and 5. So we've got that. And so, yeah, we've got these digits now that we can fill in. 1, 2, 4, 9. That's the only place for 9 in the box, though. So we've got that. This cell is an octuple of being 8. This sees an octuple of being 9. So there's a 9 over in one of these two cells. There's a 4 in box 4, J. Dyer points out. So there's a 4 up here somewhere. Let's see. These are just a 1, 2, 3 to finish off the row. Let's see. These digits we can mark in. If this is only 1, 2, 3, we're gonna have a little bit of trouble if we do that, but it's not completely a disaster. Oh, these aren't 1, 2 because there's a 1, 2 in the row, points out JLib. So these are a 6, 7 pair. I don't need anything immediately, Tristan, but thank you for asking. See, I'm looking at where 9 goes in this box, and it's a little restricted, but not completely. These are none of these are 3 or 4. That's a thing that I should update in order to get Sarah's point, or in order to get Selena's point to make sense. So the minimum of these is 2 plus 6 is 8. But if this is a 2, the minimum of these is 6 plus 7, which is 13, and I'd need this to be an 11. So Selena's point is this is definitely not a 2. So one of these is a 2. And so the minimum sum on this line is 2 plus 3 plus 6, which is 11. And so if the minimum sum is 11, that means this digit's always at least 5, although if I look at it... No, this digit's always at least 5. Yeah, 5 is... Oh, except it's not a 5. So this is always at least 5, but it's not a 5, but it's not an 8 or a 9 either. So it can only actually be itself a 6 or a 7. Well, that's bad, because there's a 6-7 pair in the row, so my math was terrible. Let's try that again. 2 plus 6 is 8. Plus 3 is 11. Oh, sorry. This is an 8 at the maximum. I maximized the sum by making this a 6, which is the minimum, not the maximum. So this is at least 3. However, if you look at this at least 3 number, it's not 5 or 8 or 9, and it's not 6 or 7 by the row. So it is 3 or 4 only. And so we can sort of mumble something about degrees of freedom, but we might not have to if I fill out the rest of this. It's not 3, 4, it's not 6, 7, it's 1 or 5. If that's a 1, there's no way I'm getting to 18, because if this is a 1, 1 plus 4 plus 3 is only 8. I'd need this to be a 10. So this is certainly a 5, and that's a 1. So these are not 1. Therefore, the sum of these is 13, for whatever it is worth. Let's see. Right. Garion has a good way to phrase this thing. I in my head, I knew this wasn't 3 because I was muttering something about degrees of freedom, but I did not want to actually say out loud things about degrees of freedom unless it became completely necessary. But Garion has a very elegant way to say it, which is that in order to get the sum to be 11, I made this a 3. And if this is a 3, I make the sum 11, so I need 2 3s in the box. This is a 4. So ways to say degrees of freedom without saying degrees of freedom is always appreciated. And so now we can fill in these. Now, certainly this can't be a 6, because if this is a 6, the sum is 10, and we said the minimum sum was 11. So now if this is a 6, suddenly the minimum sum is 2 plus 6 plus 7, which is 15, which is way too big. So this is a 3. And now we've got 3 plus 2 is 5, plus one more thing. So it could be plus 6, or it could be plus 7. It's never plus 8, because 2 plus 3 plus 8 would need to be 13, and I can't get that big. So 2 plus 3 plus 6 would be 11, would make that a 7. 2 plus 3 plus 7 would be 12, would make that an 8. So I think that really genuinely is a 7 or an 8. Now, I always used a 7 in that, because I either used the 7 here, or I used a 6 here and got a 7 there, so that's never a 7. There's always a 9 in one of these two cells, I suppose. This is a 3 or a 4. Oh, yeah, good point. Now that these are a 4 and a 5, Nicholas points out these two need to sum to 9 as well, because that basically takes care of that. We basically split it into an arrow. So if this is 1, 2, 3, and this needs to sum to 9 with this, the only way that works is 1 and 8, which makes that a 2. Good spot to Nicholas, which makes that the 2 over here, that the 3 over here, that the 4 over here. Nothing of the sort over here. That is place the 2 up here, which gives me the 6 or the 7 up there. That gives me an 8 over there. Or sorry, it gets rid of 8 over there, I should say. Oh, these are never 7, because as I said, one of these is always 7. So those cells are also indicted by that always 7 business. These aren't 2. So one of these is 2. What's left in this column? This is a naked single 1, really? It's not 2, 3, 4, 5, 6, 7, 8, or 9. Yep, this sure is a naked single 1, so that's a 6. So that's a 7 and an 8. Okay, I would have been spared if I would have been spared having to say anything at all about this sum. It's funny, I don't usually associate double arrow puzzles with parity arguments that often. They are useful sometimes, but I have not seen them show up sort of universally uh, in the way that Selena expects them to. Uh, okay, so no 2 there. So let us fill in these sorts of digits. I also wanted to fill in these digits. Thank you, Mark. It is kuraban, and this is a delightful puzzle kuraban, as I always come to expect. So the absolute maximum here is 11. Doesn't quite do it. Let's see. Wait, how are we sorting out these columns? That's what I should look at. Yeah, I was trying to prove this can't be 9. Right. If this is not right, okay, yeah, that's what I was trying to prove, and then I got confused. Right. But no, completely right. If this is a 9, then the minimum sum of these is 13, but the absolute maximum these can sum to is 11. So this is never a 9. So that is a 3, which makes that a 4, which makes that a 5, and a 1, and a 1, and a 5, and a 4, and a 3, and a 1, and a 3, and a 4, and a 7, which makes that a 6 and a 7, and a 5 and a 9 and a 2, and a 6 and a 9. Yes, you can always go back and watch the VOD later, so I hope you never feel bad if you don't make me doing one of your puzzles, which goes to anyone, of course. And the bet tree, Jaleb will be happy to notice, is a 3. So congratulations to all the 3 bettors out there. May all your betting tree wishes come true. Excellent double arrow puzzle. I really enjoyed that. I am going to finish up with some 6x6s. So there's this Rangsk coloring 6x6 that I have wanted to be doing for a while. So, but last stream went over by about 3 hours. So we'll do it now. So this puzzle, if you have not been part of the many discussions about this puzzle, is a standard killer, but with the bonus that we get to use uniqueness on it if we want. We are allowed to use uniqueness. And so the thing I see immediately about uniqueness is that these two 5 cages can't be the same. Because if the two 5 cages were both 2-3, then the point is that I could do this combo 3-3-2-2, or I could do 2-2-3-3, and that would break uniqueness. And so this is actually the basis of a standard Sudoku technique. If you've not seen this before, sorry, that would not be a good example of using the standard Sudoku technique. So if you learn classic Sudoku puzzles from apps or whatever, they will teach you that if you ever have this pattern in a grid to a Sudoku puzzle, this is what's called a unique rectangle. Still not a good example. You're right. It's still not a good example. I'm just trying to push them apart so that it's not. Yeah, it's like they have to be in the same box. So I made it use those, and that was still not the same box. Okay, so it's not very interesting in a 6x6 is the point. Yep, there we go. If you have this kind of arrangement, and they can in a 9x9 be more spread out. I suppose I should do it vertically like that. Yeah, I should do it vertically is what I should do. There we go. Okay, as I explain this technique. So if you study classic Sudoku solving and you want to do it quickly, this is one of the patterns they teach you to look for. And so if you ever come into this pattern, and you'll see this all the time in Sudoku we're solving on the channel, and I'll occasionally remark on it, this is what's called a unique rectangle. If I make this digit a 2 or a 3, then I force there to be 2 solutions to the puzzle. And that's too many solutions to the puzzle. So if you encounter this, you can immediately just write a 5 in the puzzle anytime you want. Now, you'll notice on this channel, excuse me, on this channel, I rarely use that deduction or variations thereof. And the reason is that in order for that deduction to be correct, you're assuming that the puzzle only has one solution. The contradiction you get from this cell not being 5 is not that the puzzle has no solution, it's that the puzzle has more than one solution. And so generally, I go with the Sam Kappelman-Lynes interpretation of puzzle solving, that when you're solving puzzles, your goal is actually to prove the puzzle has a unique solution rather than to assume the puzzle has a unique solution and find it. But of course, if you're solving quickly, then you don't want to do that. But for purposes of this puzzle, we're explicitly encouraged to use uniqueness, so of course we have to. And so the point is that there's exactly 2 ways to make 5 cages in 2 cells work. And so these must therefore be different ways of making a sum to 5. Now, I have no idea if that's going to be useful in any way, but we get that at the very least. We have that. So neither of these 5 cages is in the 10 cage. Right? Oh, actually, sorry. These are just both red. Never mind. Sorry. These are both red. Because where does red go in the bottom line? Sorry, I was thinking about this wrong. Where does red... No, I was right. Sorry. Neither of the 5 cages is in this 10 cage, and therefore there's not a 5 in the 10 cage, and therefore that's a 5, and that's a 4 is the point. And we get a donation from David, who donated $6. It's always a pleasure to see one famous setter and streamer solve another famous setter and solver, especially with the setter present. Thank you, David. Thank you so much. Let's get you a donation dance. Woohoo! Woohoo! Thank you, Zach. Thank you. So that's the point, is that I can't have a 5 sum in this. So to do that, and so therefore these are 2, 3. Therefore these are 1, 4, and we can write them in. And therefore there is a 1 in this cage, because the only way to make a 10 cage without is 2, 3, 5, which this is definitely not. So that's a 1. And now these need to sum to 9 as 3 and 6. And so that is a 2 and a 3. That now is a 6. These are a 2 and a 5. And we've got all kinds of digits all over the place. The only 2 ways to make a 9 cage in a 6 puzzle, or in a 6x6, are 4, 5, and 3, 6. So this must be 3, 6. And these, therefore, are 1 and 2. But that can't be a 1 because it would put a 6 there. So that's 2 and 5, and that's a 1. So there's a 2 over here somewhere, for sure. Yeah, so there's now... Right. So I should have thought about that before. Right. There's another uniqueness argument on 9 cages, because, as I just said, there's only 2 9 cages in existence. And so in a 6x6, which is just the 5 ones I saw right away, because it's also only 2 options in a 9x9. But in a 9x9, there's a bunch of 2-cell 9 cages. But in a 6x6, there's only 2, and so this again can't be 3, 6. It has to be 4, 5. And if that's 4, 5, thank you for that, Ambrose. That's 4, 5. That's a 2 and a 5. And so that's a 5 by Sudoku. Up there. So this 7 cage doesn't have a 5 in it, so it's not 2, 5. And it's not 1, 6 either, so it's 3, 4, and I know the order. 6, 5, 3, 4, 6, 3. Did we ever use this 7 cage? I kind of feel like we never used this 7 cage. It was probably intended for some other purpose. But I think we solved it without the 7 cage. Oh! I bet it's not unique without the 7 cage. It did not occur to me that clues might have a purpose other than something for helping the solver. So 3, 4, 6, 1, 5, 6, 1, 5, 2, 1, 2, and 6. But yes, I bet that is exactly what happens, is I bet it's not unique without the 7 cage. But that the 7 cage is not used in the sort of path. Was that roughly how you intended that uniqueness be used, Rangsk? It was super cute to use the uniqueness thing on 9s that Ambrose saw. I would not have gotten that for at least for a while. I'm not sure how long it would have been eventually for me to get it, but we have that. Let's see. We've got time for another 6x6. Let me scroll back a ways, because there's still some 6x6s from ancient times that I have not ever gotten to, and I like to try to get to them. Although I try and remember to only do the ones that someone has tested. So if I've not done yours and it's because no one has tested it, you should ask someone to test it. Although sometimes I do ones that are untested by accident. Let's see. Oh, was I scrolling past a bunch that I have not? Oh, I was suddenly accidentally scrolling past a bunch that I haven't done. Let us do this DJV one. That's some snake, I am being told. So here we have a normal 6x6. There's a 1 cell wide snake in the grid that starts and ends at the given circles. So these are snake cells. The snake must visit all 6 boxes and forms a region sum line in which the sum of the digits along the line and snake in each region must be the same. Given squares denote cells that are not on the snake. So we can gray all of these. Cells that are not on the snake. And the number placed in the cell counts the number of cells in the surrounding 3x3 box, including itself up to 9, although, of course, 6x6 is only up to 6, that are not on the snake. So the snake has to visit this box, and so the only way it can possibly visit this box is by doing that. This is supposed to count the number of cells not on the snake, so that's a 2, because it sees these 2. So the sum is not 6. And this now must be a 1. Sorry, this must be a 3, actually, because it can't be a 2, and so that means this cell's also not on the snake, in order to make that a 3. It cannot be a 4. How could it be a 4? There's already 3 cells on the snake. I don't think it can be a 4. It's counting cells not on the snake, not cells on the snake, Jaleb. Which is a little weird. I got that right? Counts the number of cells that are also not on the snake. Yes, okay. I did get it correct this time. So we have that. Okay, of course this is on the snake, because the snake has to eventually connect to there. Now, if this is a 1, that seems like this is going to be a huge problem. Because if this is a 1, the sum is 15. And that doesn't sound good to me, but I'm not 100% convinced that that's not possible. But it sounds very bad to me if the sum is 15. Oh, it's just forced by squarity, right? This is forced by squarity, as MicroStudy says, right? Because this number is not 2 or 3, but it's at least 2, but it's at most 4. And so if you combine all of those things, it is 4, and we get that, which then greens that cell and tells us that the sum is 21 minus 9, which is 12. So we're always going for a sum to 12, which means this cell's not green. Because if this cell was green, there would only be 2 snake cells in here. It visits each box exactly once. No, but it would be incapable of revisiting this box, right? If this is green, the snake does this, and it can't revisit this box no matter how hard it tries. So that is gray, and these are green. Now, the snake doesn't finish, or it would be a very short snake. That's green. The snake doesn't finish here either. So we get all of that. The snake can't sort of branch. The snake can't branch. The snake must continue until morale improves. So these sum to 12. Oh, this I know. This is 3. And so this is 1, 2, 4, 5. Because that's the only way to make 12 and 4 without a 3. So those aren't a 4. That's not a 2. That is a 6. So these are from 1, 4, 5, I suppose. Let's see. One of these two is a 3. Yeah, these are from 1, 4, 5. Okay, so right, this is a 3-cell 12 sum, not a 4-cell 12 sum. Okay, got it. So this is a 3-cell 12 sum. I should keep that in mind before I make deductions that are wrong based on the idea that it is some other thing. I can't have both 3 and 6 here. This is a ridiculous deduction, but I saw it, so I'm going to write it in anyway. 3 and 6 need to go in these 3 cells. They can't go in those 2 cells, or this would be another 3. So therefore, this is always a 3 or a 6. Good spot to Garian using our secret about 9s that we learned from Rangsk's puzzle. If this is a 3, these two need to add to 9, and they'd have to be 4, 5. But now I have a 1, 4, 5 quadruple in the box, which is bad. So that's a 3. Okay, so now these cells definitely have a 6 and 2 cells that add to 6. But they also have a 2. So these are 2, 4, 6 is the upshot of that. I explained that in the most confusing possible way, but that's okay. So that's a 4. So that is not a 4. Let us see. So there's a 3 and a 4 down here. So if green does, or if the snake does that, there's a 3 and a 4 down here, and then I'd need 2 digits that sum to 5. That doesn't work, right? Okay, so here, bifurcation palette time. If the snake comes here, it goes up there and then finishes in some way. But I claim the snake doesn't do this because the 3 and the 4 end up down here, which means they're both part of the sum along with 2 other digits, but those 2 other digits need to add to 5, but you can't because the 3 and the 4 are gone. This really is a nice companion puzzle to Rangsk's puzzle, because we've used both stuff about sums to 9 and stuff about sums to 5. So we do that. I highly doubt that was the intended way of deducing that, just for the record. Uh-oh, I screwed it up, because now this is a 4. How did I screw this up? I thought my logic was very sound, but my logic was apparently not sound because something is wrong. Because now this is also a 4. Oh, it's because once I get here, I got it. Okay. So what I proved is exactly this is not gray. And so this is green. But then in my brain, I just went to, and so it does this. But it can't do that. It must, in fact, do this for exactly the reason that we ended up discovering, which is that if I do that, then this is also a 4. Got it. Okay, so that's a 5. And this is a 1. And now this is 1, 2, 3, 6, because that's the only way without a 5 to make a sum to 12. So no 5 there, no 3 there, no 1 there. That's the 4 over there. Let's see. So now we've got a 3-cell sum, and this is a 3-cell sum. So if this is a 3-cell sum to 12, this is a 3-cell sum to 9, which is either 1, 2, 6 or 1, 3, 5. Well, it's not 1, 3, 5, so it must be 1, 2, 6 in order to make that work. So if these are 1, 2, 6, then these are 3, 4, 5. So that's a 4. These aren't 4. Let's just go ahead and have Mark help us with the rest of this. So there we go. So this is not a 6. This can't be 2, 4, 6. So if this is not 2, 4, 6, then maybe that's not so easy to see. Okay, well, that's a 5. That's easy to see because that's a 1-5 pair. Not claiming it's useful, just claiming it's technically true. These 3 are a sum to 9 again. And the sum to 9, I'm saying, is not 1, 3, 5, because if it was 1, 3, 5 over here, it would be that. So the sum is either 2, 3, 4 or 1, 2, 6. It can't be 1, 2, 6. Because these would need to be a 1, 2 pair, and they can't be, or because of that. So from the row, it's not 1, 3, 5, and from the column, it's not 1, 2, 6, and therefore it's 2, 3, 4. That's very cute, actually, that geometry of ruling out the 2 ways of making 9. So that's a 4. And these are, and that's a 3, and that's a 2, in order to make that work. So that's a 6 and a 2 and a 4 and a 1 and a 2 and a 1 and a 6 and a 1 and a 3 and a 6 and a 2 and a 5 and a 1 and a 5. And a 1 and a 6 and a 5 and a 3. And we have successfully solved the snake puzzle without using uniqueness. Nice puzzle, DJV. I realized that this is from... Actually, it's not that long ago. It's only from April. I was thinking this was going to be from like a year ago or something. But very nice puzzle. And a good puzzle to wrap up stream on. So thank you to everyone for joining today. We had a lot of good puzzles today. It was the first time in a bit that we got to do some regular Sudokus that were great from Tallcat and Kuraban. A very neat puzzle from Math Pesto as well. So thank you to everyone who came to the stream. I always enjoy it. Thank you for liking the stream. If you've not yet done so, please do like the stream. If you're new, please consider subscribing if you have not yet done so. I think actually I have a higher than average for YouTube subscriber ratio of my typical viewers, but if you're not yet subscribed, please do. And thank you to everyone who supports the channel. It really does help to keep this all going and making sure we get our sort of 2 to 3 streams a week on a regular schedule going. Sorry that the schedule's been a little messed up. I can't promise it will be unmessed up in the next 2 months, but it will be unmessed up after the next 2 months. But in the process of moving to an Airbnb and moving to a house, I have no idea exactly what the schedule will be. But I'll try and continue updating, and we'll try and continue having them scheduled, all of that. If you would like to support the stream, there's a couple ways you can do that. You can make a one-time donation by going to this Ko-fi link under my face. Or if you prefer to become a YouTube member for as little as $5 a month, you can get access to all of the Zach Love emotes and support us that way. And then you get the green name in chat and all those sorts of things. There are plenty of people who support us other ways as well. All the names of the people who support us on YouTube and Patreon are listed on the splash screen, so you'll see their names very shortly. Sarah asks if Tristan is going to stream again at some point. I think Tristan's plan is that he's going to join in on our guest streams when we start having regular guest streams again. So so we're going to do that once we're set up in the new house, because the Airbnb is not well set up for having guest streams. So I think that's the plan, is that we'll continue to, like, every other Sunday have streams with guests, and I think Tristan intends to join for those. Or something morally equivalent to that is the plan. To wrap up, I'll also thank all the people who support the stream at the top level, people who've been incredibly generous, so thank you so much to all of you. David Ratner, Nordy, Franco, Woofer, DDX, Daniel Silverstone, Willie, and Danita, thank you so much for your generosity, and I will see you all very soon. Thanks for watching. Bye for now. And then I awkwardly look at the stream deck trying to find where the ending button is.